Good morning, respected physicists, my dear participants. I welcome you all to the third day program of this 12th Biennial National Conference of Physics Academy of Northeast. We are going to start fifth technical session on nuclear physics and high energy physics. And this session will be chaired by Professor B.M. Jerwa, Department of Physics, NEHU. I request Madam to kindly take over the charge. Madam, please.
Hello, thank you. Good morning, everybody. So I would like to invite Dr. Faisuddin Ahmed from the Department of Physics, University of Science and Technology, Meghalaya. His topic will be effects of Coulomb-type potential with uniform magnetic field on generalized Klein-Gordon oscillator using the Kaluza-Klein theory. Your time is, I think, 20 minutes, and perhaps one or two questions can be asked, short questions. The rest, you can approach the speaker via email due to time constraint. Please go ahead, Dr. Faisuddin Ahmed.
Thank you, ma'am. Good morning, everyone. So my talk is effect of potential and the magnetic field on a scalar particle, or basically we say the spin zero particle, in the background Kaluza-Klein theory. So Kaluza-Klein theory, as we know in general relativity, it is the extension of four-dimensional space-time into fifth-dimensional, where general relativity and electromagnetism were unified by these two physicists. So let's discuss. Before that, I need to introduce a few things here. The line element of cosmic string. Space-time in fifth-dimensional geometry is given by this one. So this geometry is different from Minkowski due to the presence of this parameter, that is alpha, which is called the West parameter. And this is related to the linear mass density of the string. This cosmic string space-time basically are the exact solutions of the field equations and one-dimensional topological objects. There are many topological be there in different dimensions. If you basically say 0 dimension, it is the magnetic monopole. If we say 2 dimension, then it is represent the domain wall. And the cosmic string space-time basically one-dimensional topological objects. So this parameter has some peculiar in the sense, or in comparison to the flat space, is that this space-time is locally flat. It means that the local objects can go unaffected around it, the string, but globally it is not flat. So there is a curvature singularity on the symmetry axis, which is I did not show here. Actually, related to this parameter alpha. See, if we take this parameter alpha equal to 1, then this curvature equal to vanishes, and this space-time is flat space. That means no Riemannian tensor. So in gravitation and cosmology, we basically take the values of this Weiss parameter 0 to 1. So here this y coordinate, so this is the additional. So this is the fifth coordinates that we have added with the four-dimensional space-time, because we can edit 1 plus 2-dimensional space-time into 1 plus 3 by adding a spatial coordinate. Similarly, in 4 plus 1-dimensional space-time, we can add another coordinate. So this coordinate is the spatial coordinates. So this coordinates have some restriction will be there. So that is then extra dimension, because extra dimension has a lot of applications in different branches of physics. People are working on the various extra dimension. So this y coordinate has the range of this one, where a is the radius of this compact dimension of the y. And the race coordinates are goes to these ranges, t, z, r, and phi, this one. So here this phi coordinates ranges from 0 to less than twice pi. So it means that if an particle or if an observer, you can say, move in a circle in this space-time, then he or she return to the same point with an angle less than 360 degree. So it seems impossible, because we know in Euclidean geometry, a particle moves in a circle starting from one point, and for one round trip the angle is 360. But in cosmic space-time here shows that the particle is starting from one point, and for one round trip, that means reaching the same origin point, so angle is less than 360. So this only happens due to this wedge parameter alpha present in the space-time. So that is called the angular deficit. So is given by this one. So if alpha equal to 1, so there is no angular deficit, and the geometry is a flat space. Now the idea behind the introduction of this additional space-time has found wide applications. For example, in quantum field theory, in string theory. So this through this extra dimension, so one can introduce this electromagnetism. So that was done by these two physicists, Kaluza and Klein, in this way. So the unification of gravitation and electromagnetism. So through this fifth dimension by a minimal substitution of this one, where K is a Kaluza constant and M is the electromagnetic 4-vector potential. So here the range is given. So this is the way we can unify the gravitation and the electromagnetism. This Kaluza-Klein theory has been investigated in different scenarios, with the torsion or with the fermion. One can study the fermions in the background of Kaluza-Klein theory. This Kaluza-Klein theory has been also investigated in Lorentz symmetry violations, in standard model extension. This Kaluza-Klein theory has studied in the scalar fields, and this theory also in quantum mechanical system. Many people researchers study this Kaluza-Klein theory in quantum mechanical system. Then in Grassmannian context, this Kaluza-Klein theory is the name Grassmannian Kaluza-Klein theory, and this Kaluza also is studied in standard model, and so on. So based on this one, the generation of topology will defect space-time. We will follow these two. One is a magnetic cosmic string, and another is a magnetic chiral cosmic string, that have been studied in the context of the Kaluza-Klein theory. So these two space-time have been studied because it gives some interesting phenomena. So based on this generalization of the space-time, so there is an interesting effect that is called the Aharonbaum effect. And this effect has been studied in the magnetic cosmic string space-time and the magnetic chiral cosmic string space-time. This effect, in the context of the Kaluza-Klein theory, has also been studied in the graphene. So in this work, so we introduce a uniform magnetic field B, because in this extra dimension where we have done this minimal substitution, so where this M is the electromagnetic potential, so we have introduced this electromagnetic potential, the magnetic field, and we consider a magnetic flux. This magnetic flux is produced by the topological defect space-time. So therefore we have considered this 4-vector potential, which is a Gauss field, is given by this one, and the rest components are 0. So therefore electromagnetic 4-vector potential is given by this one. So if one calculate the magnetic field using this 4-vector potential, one will get this one, the magnetic field along the Z direction. So therefore, based on this Kaluza-Klein theory, therefore the line of a magnetic cosmic string and one magnetic chiral cosmic string. So here we consider the magnetic cosmic string in the 5th dimension. So few works have been done in this direction with the different some others, maybe absence of magnetic field, maybe absence of magnetic flux, or maybe there is no potential. So in this work, we have this is the line element based on this Kaluza-Klein theory, and this is the cosmic string spacetime. Now the question is why we need to study. Why we study? Because in quantum mechanical system, an ideal solution can give the complete information. If anyone wants to know the system, quantum mechanical system, then ideal solution is necessary. Second thing, the analysis of gravitational interaction with the quantum mechanical system has attracted attention in recent years. This one is the works is going on, the unification of gravitational interaction and quantum mechanical system. And the third one is important. They study quantum mechanical problems in Karp spacetime. So before the Karp spacetime, so several authors have studied in Minkowski flat space, the unification, gravitation, and quantum mechanics through the Minkowski flat space. So here, the Karp spacetime gives another direction that one can study the unification of, one can study or they analyze the gravitational interaction and quantum mechanical system that has been studied nowadays. So therefore, the relativistic quantum dynamics of a scalar particle, or basically we say the spin zero particle, is given by this fifth dimensional. This is the Klein-Gordon equation in fifth dimension. So since we consider the magnetic cosmic string, so G is the metric determinant of metric tensor and G is the quantum metric tensor. So here units C and the 1. So based on the fifth dimensional magnetic cosmic space time, one can arrive these equations. This is the wave equations. So where K phi is given, that is the electromagnetic force vector potential is given in earlier in terms of a uniform magnetic field and magnetic flux. Now, here we consider in quantum mechanics, by separating the variables, one can choose the total wave function in terms of radial wave function. Here in this work, we are interested to introduce a scalar potential. So this scalar potential has been can be introduced in two ways. One is by minimal substitution of the partial derivative, or minimal substitution, del mu equal to del mu minus I a mu. Since mu is already present in the system, so therefore we consider another kind, that is by transforming the mass in the Klein-Gordon equation. So this one is first given in 1971. It is appeared in this paper and subsequently used many authors to study the relative quantum system. For S is studying a scalar potential. So therefore, if one introduces a scalar potential, so then one will arrive to this second order differential equation. Still, we didn't put this A phi, and still this SR is an unknown scalar potential, maybe of different kinds. So in this work, basically we are interested in the potential which is inversely proportional to the axial or the polar distance, or the radial distance. Why consider? Because this potential has studied in particle physics in the propagation quark model and in the propagation of gravitational waves that appeared these two papers. This potential is called Coulomb type because it is a positive nature. So this lambda c is greater than 0. That is why we call it is a Coulomb type potential. Secondly, this potential have been used in condensed matter physics system. That is appeared in various journals as mentioned here. So keeping in mind this application of this potential, we considered here this Coulomb type potential. So using this one, we can finally, this is the second order differential equation. So one may convert this second order differential equation to the Schrödinger's equation if one to solve this equation. So here we use a different one by transforming this one. We have defined this. So by transforming this a new variable, one will arrive this one. Now in quantum mechanics, The properties of this function is very important, is that this radial wave function must be regular everywhere in the range of 0 to infinity. So keeping in mind this requirement of this wave function, we consider a solution of this form. Suppose that this is the possible solution of this equation, or say is defined in earlier. So if one put this solution into the previous equation, then one will arrive a known equation in mathematical physics that is known as the given biconsequent second order differential equation, and this h is now known as the given function. So therefore, we finally derive an well-known second order differential equation. So therefore, whose solutions can be solved. Here we have considered an interesting method that is called Frobenius series solution method. If one consider this given function equal to this one, then one will find a recurrence relation, because the series solution is an infinite one, starting from 0 to infinity. So therefore, we need a finite solution so that the radial wave function must be regular everywhere. So that is only possible when this recurrence relation becomes equal to 0. That means Cn plus 2 must be equal to 0. So it is only possible when we consider these two terms. There is Cn plus 1 equal to 0 and these terms equal to 0. Then Cn plus 2 equal to 0. So then this given function becomes a finite degree polynomial function. So if it is not a finite degree polynomial solution, then the power series becomes it's not finite. So there is a win for the finite degree solution. We need to terminate this one. So by imposing these two conditions, we get a finite degree polynomial. So these two conditions gives the energy eigenvalue of the scalar particle of the for each radial mode. So then by simplifying this first condition, one will find the energy eigenvalues of this scalar particle in the magnetic cosmic string background in the presence of a Coulomb type potential. So this is the energy eigenvalue. The radial of function become this one, so which is now regular everywhere from 0 to infinity. So this is not the general expression, because one need to impose another condition, that is Cn plus 1 for each radial mode 1, 2, 3, 4, so that one can find the individual energy level and the wave function. So therefore, by compute for n equal to 1.
Excuse me, Dr. Faizuddin Ahmed, I think the time is up.
Yes, ma'am. Just a minute, ma'am. Okay. So if by simplifying n equal to 1, one will get that this is the condition on the magnetic field, and this is the energy eigenvalue of the ground state, or we can say for the n1, and this is the wave function. Similarly, for n equal to 2, one can find another possible values of the restriction on the magnetic field, and subsequently one can evaluate the energy spectrum and the wave function. Now, an interesting thing is that this energy eigenvalue depends on the magnetic flux, and one can see easily that this is a periodic function, where this phi naught is given by this condition. So under this condition, the energy eigenvalue is a periodic. The repeat itself, so tau equal to this one. So therefore, this wave that is the scalar particle, if rotate about the string, then the wave function gives this one. So it has few applications. So the application is given in here, because due to this one, this angular momentum shifted. So because of the presence of magnetic flux, and due to this magnetic quantum flux, so one will find the gravitational of the AB effect. So it is only in condensed matter physics. The energy levels on the geometric quantum phase gives rise to the persistent current, and which is well known. And studies of the persistent current have explored in systems that deal with the Berry phase and the quantum phase So Aaron cassette geometric quantum phase setup. So this is my reference.
Okay, thank you very much. Uh, we can allow only one or two questions due to time limit, as I said in the beginning. The rest can be sent by email to the speaker because everything is given there. So it seems we don't have any questions. We'll go to the next speaker, Professor Mrinal Kumar Das from Tezpur University, Department of Physics. The topic is phenomenological consequences of neutrino masses and mixing.
Okay, good morning.
Good morning.
So let me share my thoughts first. Can you see my talk?
Yes, it's visible at least. The screen is there.
Yes. Is it in full screen now?
Yes. It's okay.
Okay. So I think, am I audible?
Very much.
Okay, okay. Good morning. Good morning, one and all present here through online. First of all, I would like to thank the organizers, especially Professor Hussein, for the invitation. And today I will be talking about phenomenological consequences of neutrino masses and mixing. So this talk is based on my work I have done with my PhD students in recent days at Tezpur University. So we know that in panel conferences, we have the participants from different branches of physics. So for convenience of the participants, I will spend little more time in the introduction. So accordingly, I have planned my talk. So this is the outline of my talk. I have divided my talk in the three different parts. In the introduction, I will be talking about first basic building blocks of matter, then elementary particle, then I will talk about standard model of particle physics, and then I will talk about why we need to go beyond standard model of particle physics. Then I will talk about some important phenomenology related to, then I will talk about the neutrino masses and mixing, and then I will talk about some important phenomenology related to neutrinos. And then if time permits, then I will talk about some of the important phenomenology related to our work, which we have done on the basis of this minimal extended and inverse seesaw. Okay, so let us start. So let us see first what are the basic building blocks of matter, and then what are the elementary particles. So we know that any
There seems to be something wrong with the connectivity.
So nothing is moving. Everything is standing still.
Yes, sir.
I think we have to call Minal. Probably he doesn't know it. He's continuing.
There seems to be some network problem.
Yes, calling. Hello. Yeah, I just contacted Minal sir. Actually, he is aware of the problem. There is some network problem in his side, so he's fixing it probably. Okay. Just we'll wait. Yeah.
স্যার ইন্ট্রোডাকশনটো যে এটমৰ কৰিছে তাৰ পৰা অহা নাই সাউন্ড
What Jugal?
স্যার সরি আই
Yeah.
No,
He's not connected yet. He's trying. Okay, he's trying. No. Okay, fine.
yes sir he is in my nearby cabin I have told him
Okay, fine.
he is arranging
What should we do, sir?
Maybe we can, Madam. Maybe we can move to the next presenter. So after that, we can come back.
Since time is running, I think I would request now the oral presentation, and then we might come back later on because there's some connectivity problem. So may I request Nayana Gautam from Tezpur University to start off. Your time is 8 minutes plus 2 minutes for questions, if any, and then we'll proceed. Nayana Gautam from Tezpur University. Is he here? Now we're starting the oral session. Is Nayana Gupta here in the group? Or there's something wrong? Or is he absent?
Hello, I am sorry, I am back. Because of this network issue, I am extremely sorry for the inconvenience. I joined with my student's account. It is showing Jotin Gogoi. Sorry, madam.
Okay, it's all right.
Let me share my screen again.
Okay. Please go ahead.
Yes.
Please continue then. Or is it a network problem? I think Professor Mrinal, you can resume at the end of this oral session. Is Nayana Gautam here? I've been calling his name.
Yes, madam, I am done. I am sharing my screen.
Pardon?
I am sharing my screen.
it's too late
So Minal Das is sharing, ma'am. Yeah. So Minal Das is sharing. Yeah.
Okay, so can you hear me?
Yeah, sure. Go ahead.
Okay, so I am extremely sorry for the inconvenience. I think I start in the second slide. So that was in the basic building blocks of matter. So we know that any kind of matter in our universe, I mean visible matters are consist of molecules. Molecules are consist of atoms, and atoms are consist of nucleus and electron, and nucleus is again consist of proton and neutron, and this proton and neutron is again consist of some elementary particle called quarks, and quarks are inside the nucleus with some strong force through gluons. And so far our knowledge is concerned, we know that these quarks, electrons, and gluons are the most fundamental particle in our universe. Along with all these fundamental particles, we have a lot more fundamental particles in our universe, along with the neutrino. So, according to that, yes.
Excuse me, the slides are not visible.
Lights are not visible.
Let others.
Yes. Now it is visible.
No.
But here it is visible and it is changing.
But from this end, it's not visible.
Maybe because of the network issue. Now it is visible or not?
No, it's not visible.
My screen is shared with you all.
No.
Sorry?
No, sir. Actually, the screen is not shared.
The screen is not shared.
Yeah.
The screen is already shared. No?
No, maybe you can just disconnect. I mean, just disable the sharing once and then again share.
No, I think we should go to the oral session.
Yeah, it will be better.
So Nayana Gautam is not here. I've been calling him several times.
So what I can do?
No, we'll come back in the end.
At the end,
Can
at what time?
resume. This will finish, I think, by 12.
Well, okay.
This oral session. And perhaps after 12.
Okay.
But it looks like Nayana Gautam is absent. Has he joined?
Ma'am, I am present here.
Oh, so sorry, because it doesn't say Miss or Mr.
Okay. I will be presenting to the account Jyotin Gogoi. There are some internet issues in our university. So I will be presenting through the account Jyotin Gogoi.
Accounts of?
Jyotin Gogoi.
Okay. Please go ahead. Nayana Gautam, please go ahead. Miss Nayana Gautam.
Okay.
Naina, if you want some time, you can take actually. If I need to present, I can present.
No,
or we'll go to the next.
Fine.
If it is, if you have some network issues, if you need some time, then I mean.
Then we'll go to the next speaker. Tapash.
Is it visible?
Yes.
Is it visible?
Yes, I am present, madam.
Yeah, it's
I
visible.
think, but it's
Is
very
it visible?
blurred.
My screen.
Your screen
very
is visible.
blurred.
You can go to the presentation.
Yeah. Can you see my presentation now?
Yes.
Yes. So your time starts now. So by 11:15 it should be over. Sorry, 8 minutes you take, and then perhaps 2 minutes for questions.
Okay. Thank you. Good morning, everyone. The topic of my presentation is impact of texture zeros on leptogenesis within minimal inverse of framework. This is the brief outline of my talk. Am I audible? This is the brief outline of my talk. I will start with introduction on topic baryon asymmetry of the universe and the framework that has been chosen to study. This is the inverse seesaw 2-3 framework, and next how baryon asymmetry can be generated in this framework. Then I will discuss about texture zeros in inverse seesaw 2-3 framework, and then results and conclusion, followed by the references. So what baryon asymmetry actually is? In Big Bang theory says that all physical processes produce equal amount of matter and antimatter. So we would expect equal amount of matter and antimatter in the current universe. If these are created and destroyed equally, then we would have left with only energy. But this is not happening. We are living in a matter-dominated universe. So this asymmetry between matter and antimatter is termed as baryon asymmetry of the universe, which can be qualitatively expressed as equation number 1. And this non-zero value of baryon asymmetry demands physics beyond standard model, because successful standard model of particle physics cannot provide a viable explanation towards the baryon asymmetry of the universe. So in Shakarov in 1967 put forward 3 important criteria for baryon asymmetry. Baryon number violation is a trivial condition. C and CP violation are needed so that the interactions that produce more baryons than antibaryons are not counterbalanced by the reverse reaction. And departure from thermal equilibrium is another important criteria for baryon asymmetry of the universe. And there are different mechanisms for generating baryon asymmetry. And among these, we are interested in baryogenesis via leptogenesis, where lepton asymmetry is created first, and then it is converted into baryon asymmetry through Spelleran process. And in this work, we have studied resonant leptogenesis, which is a low-scale leptogenesis. Now let us come to the model. We have considered an inverse seesaw 2-3 model where 2 right-handed neutrinos and 3 sterile fermions are added to the standard model particle content. And the mass matrix M is given. M is a combination of Dirac mass matrix MD, Mn, and mu. And this particular model can lead to 3 light-active neutrino states in sub-eV range, 2 pairs of quasi-Dirac particles, and 1 sterile neutrino in keV scale. Since this model contains 2 pairs of quasi-Dirac particles that are in keV scale, this may decay into leptons and anti-leptons, creating lepton asymmetry, and then it can be converted into baryon asymmetry of the universe. And these are the governing equations for the calculation of baryon asymmetry. There are 2 important parameters, CP asymmetry parameter epsilon, and another important parameter is the efficiency factor kappa. In epsilon, the CP asymmetry parameter epsilon, we have the Yukawa couplings in mass basis H and H stellar. These are the Yukawa couplings. And in inverse seesaw model, the Yukawa couplings are complex, and these are the sole source of CP violation in this model. And efficiency factor depends on the washout factor as given in this slide. Then we have expressed all the Yukawa couplings in mass basis in terms of the Yukawa couplings in flavor basis. Here, Y represents the Yukawa couplings in the flavor basis, and epsilon depends on the elements of the mass matrices mu and Mn. And after calculation, we can obtain the CP asymmetric parameters for this. For the decay of the quasi-Dirac particles in terms of the Yukawa couplings in flavor basis. After this calculation, we have expressed all the terms involved in the calculation in terms of our model parameters F, Z, and P. Then let us see the texture zeros possible texture zeros in this model. There are three possible 1-0 textures of light neutrino mass matrix in this model that arise from the maximal zeros in MD. This can be divided into three classes, A, B, and C. And for class A, we need to consider the mass matrices given in equation number 24. And the mass matrices given in equation number 25 lead to the class B, and we obtain class C by considering the mass matrices given in equation number 26. Then in class A of mass matrix, M nu has 0 at 1, 2 position, and in class B, M nu has zeros at 2, 3 position, and in class C, M nu has 0 in 1, 3 position. After constructing this texture zeros in this model, the next task is to evaluate the model parameters. For that, we have used the conventional diagonalizing technique for the light neutrino mass matrix, that we diagonalize it with PMNS matrix, which contains the model parameter, neutrino oscillation parameters that we have taken from the latest neutrino oscillation data. That these are given in this table 1. After this, after evaluating these model parameters using equation 30, we then fit these model parameters in the calculation of variance symmetry in all the textures, and the results found are shown here. From these results, we see that the texture A1.
I think the time is up now.
Variance.
Hello, excuse me.
I'm
Miss
coming to the
Nani.
end of this talk. Just
Okay.
one.
So these are the results.
Okay, thank you, ma'am. The texture A1 leads to correct Bayesian asymmetry of the universe. The texture A2 yields very small amount of Bayesian asymmetry, which is discarded by the cosmology data. And in case of A3, we see that a small parameter space is available, which is in good agreement with the current cosmology data. So these are the parameter plots for model parameter K2, K3, and K4 respectively. So in conclusion, we may say that this model is successful in explaining variance asymmetry as well as neutrino phenomenology. Another important conclusion that can be drawn.
Okay, any questions from the audience?
Thank you for your attention.
Any questions? If not, then we thank the speaker, and may I invite this next speaker? I think she must be Miss, because somehow there's no Miss or Mr. mentioned. Tapashi Das. Is a person here?
Yes, ma'am.
Okay, so you are a lady. Miss Tapashi Das from Madhab Chaudhary College. The title of the topic is something to do with the, I've missed that. Okay, when you show on the screen, it will be visible. So please go ahead. Your time starts now. All the best.
Okay, is my screen visible, madam? Madam, can you hear me?
Yes, yes.
You're very audible.
Yes, yes.
Yes, screen is visible, right?
Yes,
Okay.
very much.
Okay.
Please go
Thank
ahead.
you. Okay.
Welcome.
Ma'am, I am Tapasya Das from Madhab Chaudhary College, Borpeta. The title of my presentation is to entry to effect in the RMS radii of heavy flavored measures in a QCD potential model. So I'm skipping that step. Okay. For the development of the potential, the source of the potential is the first step. For in our case, we have considered a Cornell potential where one term is the Coulomb term, which represents the shorter range part of the potential, and another term is the linear term, which is the responsible for the confinement of the quarks, and it represents the long range part of the potential. So in this work, we have incorporated the two loop and three loop effect in the potential. So this is the three loop effect in the potential in the momentum space, which has been taken from this paper, and we have transformed it to the coordinate space. which will be like this. Here the first term is due to the one loop effect, the second term is from the two loop correction, and the third term is from the three loop corrections. And after that, we have found a relationship between the alpha V, which is the corrected, or we can say the modified coupling constant, incorporating the loop effect, and alpha S is the strong coupling constant, which we get from the MS bar scheme. So after getting the relations between the alpha S and alpha V, or transforming it to the alpha V, the next step is to find the solution of the Schrödinger equation. Since the exact solution of the Schrödinger equation is not possible, so we have used the Delgarno's method of perturbation. So for that, the potential here, E minus V, the potential, for the Cornell potential, we have two choices to make. One is to taking the Coulomb aspirant and then linear perturbation. And for source 2, we have considered the linear aspirant and Coulomb perturbation. So for source 1, we have found a wave function which will be like this. Psi C total is given by equation number 7, with, where n is the normalization constant. And similarly, we have found the wave function for linear aspirant and Coulomb perturbation. Here, the wave function will be a series solution will be like this, where A0, A1, A2, A3 are the coefficients which are given as in equation 12, 13, 14, 15. So after getting all the coefficients, we have found the RMS radii. Let me come to the slide. Okay, this one. RMS radii of the mesons. Actually, RMS radii of mesons means that it gives the average size of the bound states of the quarks and the antiquarks. So for the source one, which is the Coulomb aspirant linear perturbation, we have used the wave function psi c here and find the root mean square radius. Here are the results. Actually, in literature, the results for only harmonium and plutonium are available. These are the results which have found earlier using the strong coupling constant Emmonsburg scheme. But here in this modified model, the results found to be improved, especially for the wave function, Coulomb aspirant and linear perturbation. But for linear aspirant and Coulomb perturbation, here the harmonium values are much less than the plutonium scale. So we can see that our results have been modified in a way by taking the loop effect consideration. So to conclude, our analysis indicates that two and three loop effects play an important role in the root mean square radii of heavy flavored mesons. However, the result shows the improvement over the previous ones, especially with the wave function constructed from the Coulomb potential aspirant and linear perturbation. Okay, thank you. Is there any question? Yes, please. Hello? Hello, am I audible?
Yes, madam.
Yes, any question? I can see a raised hand.
Please go ahead and ask the questions. We can't hear the question. It's not audible. Okay, then we'll go ahead with the next speaker. The next speaker, I think, is Miss Paramita Deka from Guwahati University.
Yes, ma'am.
Your time starts now. Please put up the screen. Very good morning to you and all the best.
Thank you. Good morning to you, ma'am.
Thank you. Where's your screen?
So I'm trying to share my screen, but I'm not able to share it. Is my screen visible? Hello, ma'am.
No, there's a lot of distortion.
Stop your sharing. Yeah. Now again you start.
Please start.
Is my screen visible, ma'am, now?
Yes.
Yes. Okay. Good morning, everyone. The title of my presentation is Impact of Tensors Enhancement in Neutrino Oscillation Measurements using NOVA Experiment. At present, the main motivation from neutrino cross-section studies comes from neutrino oscillation experiments. They aim at precise determination of neutrino oscillation parameters such as mass square differences and mixing angles in muon neutrino disappearance and electron neutrino appearance measurements. For this purpose, the ability to reconstruct the neutrino energy precisely is very important. As modern neutrino experiments use nuclear targets, they give rise to some challenges due to nuclear effects. These nuclear effects can smear out the reconstructed energy. So, as a major source of nuclear effects comes from the presence of multinucleon effects in which the incoming neutrino interacts with, for example, two nucleons and knock out two nucleons, creating two holes through an exchange of a meson. This process is known as 2P2H or meson exchange current or MEC. A study of transverse enhancement model is very important in neutrino oscillation experiment as it originates from MEC. This model includes the additional contribution from multinucleon process. So in this work, we study the impact of transverse enhancement in quasi-elastic process as a function of calorimetric reconstruction energy and corresponding effect in neutrino oscillation measurements using neutrino event generator in NOVA experiment. This study will help to quantify the effect of multinucleon in oscillation analysis. In any neutrino experiment, quasi-elastic-like events means the presence of events that are not pure quasi-elastic. For example, in a single pion neutrino interaction, that is an event with a charged lepton and pion in the final state, the pion can be absorbed by the nucleus during the final state interactions, or the presence of multinucleon events in a particular events. These events are considered as quasi-like events. So in this model, the enhancement of transverse part of quasi-elastic cross-section has been attributed to MEC current. So MEC final state can include two or more nucleons. So if there is no pion in the final state, then this process is considered as enhancement of the quasi-elastic cross-section. If one or more final state pions are produced, this process enhances the inelastic cross-section. So my slides. So in this work, we have considered NOVA experiment. So NOVA is a long baseline neutrino oscillation experiment designed to measure muon neutrino disappearance and electron neutrino appearance at Fermilab's NUMMI beam. The experiment consists of two functionally equivalent detectors that are placed off axis from the center of the NUMMI beam to enhance the sensitivity to muon neutrino disappearance and electron neutrino appearance. The 300-ton near detector is placed at a distance of 1 kilometer from the NUMMI beam, and 14 kiloton far detector is at a distance of 810 kilometers from the NUMMI beam. The near detector measures the unoscillated events and far detector measures the oscillated events. The main motivation of this experiment is to determine the mass hierarchy, to probe CP violating phase, and to resolve the octant of theta 2 3 mixing angle. So for this work, we use Gini 3.6 version to generate neutrino-nuclear scattering cross-section for quasi-elastic like sample with carbon as a target. We use Gini default model and Levin-Smith for charge current quasi-elastic process and Valencia model for 2p2h process. We consider local Fermi gas model as the nuclear model to describe the initial state. We have generated 1 million events for neutrino at near and far detector in the energy range 0 to 5 GeV using nova neutrino flux. And for FT spectrum, we use extrapolation technique. So for the reconstruction of neutrino energy, we consider calorimetric reconstruction energy. In this method, the energy is estimated, neutrino energy is estimated by adding all the energies deposited by all the particles observed in the detectors. It is expressed as summation of lepton energy and hadron energy. Here, EL is the outgoing lepton energy and TI is the kinetic energy of the outgoing nucleons. This epsilon is the separation energy and EM is the total energy for other produced particles. In this work, we have considered the disappearance channels as it is suitable for theta 2-3 and del m squared 3-2 measurements. And the relevant oscillation probability for this channel is expressed in equation 1. So in figure 1, we have plotted the cross section as a function of true neutrino energy for quasi-elastic and quasi-elastic like sample without transverse enhancement effect. And we from this curve we see that this black line for QE like with transverse enhancement model and this blue line for quasi-elastic only pure quasi-elastic process, we see that there is an enhancement in quasi-elastic, there is an enhancement in cross section this due to this model. And similarly, in figure 2, we have plotted the confidence region for quasi-like events in this plane theta 2-3 and del m squared 3-2 for both normal and inverted hierarchies. And we the solid line for without the transverse enhancement model and this dotted line with transverse enhancement model. And we notice that due to this transverse enhancement, there is a decrease in confidence region, area of confidence region, which indicates the better results. So we studied the effect of transverse enhancement in neutrino scattering cross-section and oscillation parameters for nova for both normal and inverted hierarchy using nova mu beam. And we observed that due to enhancement in transverse part of quasi-elastic cross-section, it enhances the cross-section as shown in figure 1 and for both QE and QE-like sample.
Hello,
and this
I think your time is
yes,
up.
ma'am. One more,
So,
yes, ma'am. So we,
any questions
thank you.
from the audience? Any questions from the audience? So thank you very much. We'll move to the next speaker, Manoranjan Datta from IIT Hyderabad. Topic is self-interacting dark matter via right-handed neutrino portal.
Hi, hello.
Hello, yes.
I hope my screen is visible.
Yes, very much. Very
Okay.
good morning to you.
Yeah, good morning. So I thank the organizers for giving me this opportunity to present our work on self-interacting dark matter via right-handed neutrino portal. So to begin with, the well-established lambda CDM model faces some severe issues at the small scale, which is one of the problem is known as the Casper problem, where the lambda CDM predicts a Casper profile with central halo density increasing as the inverse of the radius, but many observations suggest a constant core density profile. Similarly, there are many more satellite galaxies that have been predicted by the lambda CDM simulation, which is much more than those being observed, which is known as the missing satellite problem. And while one may argue that maybe there are such satellite halos which doesn't host visible galaxies, that only leads to another problem known as the too big to fail problem. That is, some of the predicted satellite galaxies of satellite halos of lambda CDM are just so massive that they're very unlikely to fail in forming stars. To alleviate these small-scale anomalies of lambda CDM, one very interesting alternative to cold dark matter was proposed by Spargel and Steinhardt in 2000, where the dark matter can have very strong self-interaction among themselves, or the order of 10 to the minus 24 centimeter square per ZeV, which is way too large than the typical WIMP annihilation cross-section. So with such large cross-section, the dark matter particles will scatter out from the dense halo center to give rise to a constant halo density. And since the satellite halos will be of less massive, so they will be more prone to the tidal effect of the host. So, however, while the small objects like dwarf galaxy with typical velocity 10 km per second favors a strong self-interaction, the large objects with large escape velocity like 1000 km per second actually favors a very weak self-interaction cross-section. So rather than a constant cross-section across all scale, we need a velocity-dependent self-scattering, which can be achieved by a light mediator in the MEV range, similar to neutron-proton scattering by the pion exchange. So one of the major issues with the self-interacting dark matter is that due to the too much annihilation into light mediator by this unsuppressed Feynman diagram, although this process can be tuned by assuming the kinetic portal or the scalar portal, whatever the way it talks to the external sector. But this process is unsuppressed, and it leads to underabundant relic. And in fact, if you demand the entire SIDM to be the whole component of dark matter and its correct relic can be obtained by thermal freeze out, then the entire parameter space has been ruled out as shown in this pioneering PRL work. However, if you do not demand that, and if you demand your cross-section, your mass in such a way that it produces the correct self-interaction at the correct ballpark, then it always gives you underabundance up to several TeVs of dark matter mass. So since then that needs your non-thermal production at late epoch, such as the freezing production of dark matter. So in that direction, and also since we know that to explain the neutrino mass, we need the right-handed neutrinos. So we wanted to ask the question in this work that can the right-handed neutrinos introduced for the light neutrino mass itself can decay at late epoch to produce the dark matter correct relic density. So to do so, we extend the standard model of particle physics by set of right-handed neutrinos that is equate for neutrino mass. Then the dark matter in terms of a vector like Dirac-Farman and the scalar phi both are charged under additionally one the charge oppositely. So as you can see, this vertex nr chi phi becomes available, and nr decay to chi and phi at late epoch, and it will give rise to the correct relic density. The self-interaction will be mediated by the corresponding gauge boson to this U1 symmetry, that is Z prime, to this vertex chi bar Z prime chi, and it is a non-relativistic phenomena after structure formation. So the scattering can be explained with the help of a equitype potential, which can be both attractive and repulsive, since the Z prime is vector boson. So the parameter space in the plane of M chi, the dark matter mass and the mediator mass is shown for the case of dwarfs, and similar parameter space can be obtained for galaxies and galaxy clusters also. For the time constant, I'm refraining myself from showing them here. So this resonance spikes corresponds to the quantum mechanical bound state formation in the attractive potential in the left hand side, while in the right hand side it is for the repulsive potential. So there is no bound state formation and correspondingly no resonance spike. And our model also shows the required velocity dependence and gives a nice fit to the available data, which is as a function of the cross section as the function of the velocity. So now the dark matter can be detected at the terrestrial laboratories via this Z prime Z mixing, and that mixing parameter can be constrained from data by xenon 1-ton experiment or a Crescent tree experiment at the lower mass region. So we can see this at for a particular kinetic mixing epsilon, all the region to the left of these curves has been ruled out by these experiments, and so it rules out the parameter space down to a very small kinetic mixing. So you're forced to work in this regime that is below 1 GeV, since you cannot go the kinetic mixing very light, further smaller also, because this jet prime, which can decay into a couple of neutrinos, must decay before Biennial in order to not to spoil the Biennial predictions. So in this region, the problem is again the relic density. So you need the non-thermal production. So for a better explanation, I'm showing here the relative contribution to the relic density with different color codes for different processes. For example, this magenta line, it gives you the freezing production from a thermal bath through annihilation process like electron-positron annihilate into dark matter. But all this process, highly produced dark matter cannot survive because it will quickly annihilate into the Z prime boson. And it will settle down to again give you underabundance as shown by this blue line, and that's where the decay of right-handed neutrino will play a role. Now, two cases may two extreme cases may occur. For example, in this case, in the left-hand side, the freeze-out cross-section of the right-hand neutrino is so small that the freeze-out abundance is too large, almost equal to the photon number density. In that case, since this has to compete with the annihilation to Z prime boson, the decay must occur too early so that the highly produced dark matter, as depicted by this red line, can still undergo annihilation to Z prime boson in order to settle down at the correct ballpark. While in the right-hand side, the freeze-out cross-section of the right-hand neutrino is just too large so that its relic density is sufficient enough to produce the corresponding relic density in the dark matter itself. So in this case, the decay of right-hand neutrino must happen sufficiently late so that the produced dark matter no longer annihilates into any Z prime boson. In between these two extreme cases, we can have a nice correlation between the cross-section and the decay width, as shown by these the curves. So coming to the neutrino phenomenology, neutrino can be explained in two different setups. One is the gauge B-L model, and one is the scotogenic model. In the B-L model, we can extend the minimal particle content by a scalar singlet. And in the scotogenic model, as we can extend by inner doublet, as it is already popularly well known. So the parameter we have here shown in case of the B-L case, the corresponding parameter space in the plan of the coupling and the ZBL mass, and this blue dotted space is the points that has been allowed, which can give rise to the cross section in the required range, as shown by this range. So,
excuse me. Your time is up now.
Yeah, this is the last slide. So this is the part of the parameter space has been rolled out by the Atlas experiment. While in case of the MEG experiment, some of the part of the parameter space has been ruled out due to large equicoupling. The same equicoupling that keeps the right-hand neutrino in thermal equilibrium will again appear in the charged flavor lepton lepton number violating processes, which can be ruled out by the MEG experiment. So to give just to the one-line summary is that probably the model at hand is the minimal model that can explain the neutrino mass and the self-interacting dark matter simultaneously. That's all. Thank you.
Okay, thank you very much. Any questions? Any questions? Then we'll call on, I will invite the next speaker, Ms. Judy T. Runga from Physics Department, North-Eastern University. Her topic is covariance analysis of efficiency calibration of sodium iodide helium detector. Please go ahead. Your time starts now.
Good morning to one and all present here. I am Ms. Jody T. Ringa from the Department of Physics, North-Eastern University, Shillong. The title of my topic is on the covariance analysis of efficiency calibration of sodium iodide thallium detector. Well, we all know that we all make mistakes in our everyday life and no one is perfect. Similarly, in our experimental measurements, none of the results obtained are accurate or precise and will always be subjected to error. Like for example, the gamma ray spectroscopy technique, which is also one of the widely used technique in nuclear physics, will also be subjected to error. Therefore, studying the occurrence of error is important as this will improve the accuracy and reliability of the results obtained. Covariance analysis is one of the methods to analyze the measurement of error. Therefore, in our present work, we study the covariance analysis to detect the error obtained while calibrating the efficiency of the sodium iodide detector using various gamma sources. If you take a note here in figure 1, this is the sodium iodide detector, which has a dimension of 3 into 3 inch. It is a flat type scintillation detector, and this detector should be enclosed in lead slabs as shown here in figure 2 in order to reduce the background interference. Again, if you take a note, this yellow point source here is the gamma ray source, which is kept 20 centimeter above the end cap of the detector. And the radiation that comes out from this source will be detected by the sodium iodide detector, which is enclosed in lead slabs. In order to calibrate the efficiency of the detector, multiple gamma ray sources are used. And for a particular gamma ray source, the experimental measurements are influenced by or governed by some physical parameters as given here in equation 1. This equation 1 gives us the formula in order to calculate the efficiency of the detector. Among these parameters given in this equation 1, the parameters that contribute to the efficiency of the detector comes only from the count, activity, half-life, and the gamma ray abundance. So this efficiency will be a function of only the 4 attributes, and these 4 attributes are measured independently. The total uncertainty in propagating the error is given by equation 2. Here, equation 2 is the sum over of all the attributes taken. It is the partial error of all the attributes taken multiplied by the uncertainty. Now, for different gamma ray lines, this equation 2 can be written in the generalized form as given in equation 3 using the law of propagation of error. The information about these partial errors and the correlation will provide us the basis for constructing the covariance matrix. This covariance matrix will represent the uncertainty and the measured efficiency as given here in equation 5. Here in equation 5, the partial errors I have explained in the previous slide, whereas this Sij alpha represents the microcorrelation between the ith gamma line and the jth gamma line for different attributes. The value of this microcorrelation matrix will be depending upon the type of attributes taken. If the attribute is independent, then the corresponding microcorrelation matrix will be an identity matrix, or else all the entries of the matrix will be equal to 1. In our study, the value of the microcorrelation matrix is an identity matrix as all the attributes are made independent to each other. Hence, with this detailed information of the identity of the microcorrelation matrix and the partial uncertainties of the different attributes, we can generate the covariance matrix. And this equation 6 tells us about the calculation of the total uncertainty, which is the square root of the diagonal of the matrix. Now coming to the experimental work and the materials and method used in order to generate the covariance matrix using covariance analysis. Firstly, the efficiency of the detector is analyzed using multiple gamma ray sources named such as the 22 sodium, 137 cesium, 60 cobalt, and 133 barium with their corresponding energy given here. And the experimental measurement were carried out using the gamma ray spectrometer. Here, figure 1 shows the gamma ray spectrometer taken from the lab. The gamma ray spectrometer consists of the oscilloscope, this gamma ray source, and the recording unit, which consists of the high voltage, the linear amplifier, single channel analyzer, and the counter timer. The various parameters that contribute to calculate the efficiency of the detector is shown here in figure 1. Here, the gamma ray abundance and the half-life is extracted from NUDAT website. Activity is given by the supplier as this is the activity during the time of manufacturing, and these counts are measured in the lab experimentally for a period of 2000 seconds using the single channel analyzer. The value of the gamma ray detector efficiency is illustrated here in table 2, which is found out to be in the range of 10 to the power minus 2, 10 to the power minus 3, and 10 to the power minus 4. Table 3 represents the partial uncertainties in which these values are calculated using equation 2 as I've explained earlier, and these values are found out to be in the range of 10 to the power minus 3. Using these values and the value of the microcorrelation matrix which I have mentioned, that is the identity matrix, we can generate this absolute covariance matrix. Now, taking the square root of these diagonals, we can calculate the value of the uncertainty of the efficiency of the sodium iodide detector, and the values are represented here in the second column. And it is found out that this uncertainty is in the range of 10 to the power minus 3. In concluding, the detector efficiency for the 4 gamma sources are evaluated to be in this range given. And for measurements that involve several variables like the gamma ray spectrometry technique, precise estimation of detector efficiency is essential, and proper analysis of covariance and evaluation of uncertainty is necessary in order to access the quality of the results. These are the references taken for my study. Before ending, I give my credit to the Almighty, and I would also like to thank Professor Jirwa, my supervisor, who has been there for me throughout the PhD period. I would also like to thank the Department of Physics, NEHU, and my gratitude also goes to all the members of the Physics Academy of North-East 2021. Thank you. So is there any question?
Very much. Any questions? There's a question from Patricia.
Okay.
Can you please speak up, Patricia? Because it flickered on the screen and then it went off, so I can't even read.
Okay. Oh, I can see the chat box. Her question is, why is covariance important for error
analysis?
Patricia, the importance of covariance analysis is because in order to detect the error using the covariance analysis method, we consider the relationship among the variables. Whereas if you consider just the normal method of calculating the error, the calculation to calculate the error is accounted mostly in just the average of the results taken, whereas covariance will also take up the relationship among the variables or parameters contributed for while calibrating the efficiency of the sodium detector. I hope this will suffice your question. I hope my explanation is okay.
Since she says her mic is not working, yeah, I think she seems to be satisfied. She said, thank you so much.
Okay, thank you so much, everyone.
Okay, then. So now I would request Professor Mrinal Kumar Das, if he is ready, from Tezpur University, to resume the talk, because it was disrupted due to connectivity problems. Professor Mrinal Kumar Das.
Madam.
Yes.
Professor Das informed me that he has some other assignment, so he could not be able to continue his talk. So maybe we missed him. So
Then what do we do now?
Then we may, continue and conclude the sessions if all the speakers is done. Oral, is there any oral left? I didn't know.
No.
Okay, then we can, wind up.
All right. Thank you very much to everybody. It's been nice hearing all the wonderful talks, and people have worked hard. So the credit goes to whether they are research scholars or whether they are teachers. They must have put in so much effort to make this a success, and thanks to the organizers also. Thank you so much.
Thank you, Professor Jerua, for your sparing your time and chairing the session in a nice way.
I don't know. I tried my best.
Yeah, it was very good, although some mechanical issue, network problem, but machine, we don't have control over it, so it's okay. As a whole, it was very nice. Thank you very much from my side and organizer, as well as from PANE also.
Thank you.
So, dear participants, let us move to the next session, and this will be a poster session, and this is the last poster session, session 3, and this session will be chaired by Professor Kushal Kalita, Guwahati University, and one announcement: all the concerned assigned poster presenters must present in these sessions. Others, they will ask or put their questions, but you must present. If somebody absent corresponding to their poster, once question is asked, then we will assume that he or she is absent in this conference. So please make sure your attendance. Professor Kushal, please. Professor Kushal, we cannot hear you.
We said, okay, now,
Yeah.
okay, you can listen. Okay, thank you very much, Professor Arshad Hussain. So now we have time. So in fact, it was assigned at 12 p.m. So I don't know whether all the poster presenters are like they are alive or they are present. So should I start now, or I should wait till 12 p.m.?
Professor Kushal,
Yes.
since we have time, we have to use it. So you can start,
Okay, fine,
and
fine, fine.
if somebody is absent, we can repeat it in due time also.
Okay, fine, fine. Let me start. So in fact, there are many posters. So let us start from 50 cmps. So I'll just name one by one. If also at the same time. So I got some of the question from the chat box for the participants. So I will also ask in between, and maybe I have also some doubts. So I also clear those doubts. So this is 50 cmps. Are you available? Devankita Ghosh, Tripura University.
Yes, sir.
Okay. Yeah. Okay.
Sir.
Yeah. Yeah. Good afternoon.
Good afternoon, sir.
Okay. Fine. So one of the questions, because you have done a good things. This is experimental one. So can you define luminescence phenomena? And another question is on what factors does this efficiency depends?
Sir, can you please repeat?
First of all, you define luminescence phenomena. Okay. Then second question is on what factors the efficiency depends. There are two questions. Can you get the questions?
Okay. So the first question is luminescence phenomenon. Okay.
Yeah.
So it is the actually the spontaneous emission of light by a substance which is not resulting from heat. So yeah. Actually, this is caused by the chemical reactions and electrical energy or the subatomic motions or stress on the crystal.
Then what factors this efficiency depends?
Its efficiency can be actually its efficiencies depend on the radiation absorbed by the material.
Radiation absorbed by the metal, or it will also depend on the detecting setup.
Yes.
Because it will also depend on the geometrical
Yes,
factors of the setup.
Yes.
Exactly.
Yes, sir.
Okay. Another question from the chat box. With 50 cmps, can you please explain the term quaternary alloy and how it can be applicable in practical field? This is asked by Juipal.
Okay, so the alloy is basically the mixing of two or more binary compounds. So it can be possible by doping two or more impurities in a basic binary compound. So in my case, it is a quaternary alloy where I doped two elements in the basic zinc selenide binary compound. And the second question, sir?
Practicability. What about the practicability?
Okay, so the alloys are basically, made for tuning the band gap. So the zinc selenide, from studies we know that the zinc selenide is the band gap of about 2 point something, and for MgSe it is about 3, and for beryllium selenide it's about 4 to 4.5.
So mixing these alloys gives a wide range of band gap from the range 2.3 to 4.5, which we can use them in today's target-oriented application.
Okay,
As for
okay. Then another question by Kishal Lloyd Devnath. So that it is in the same way. What is optoelectric property? Electric property, electronic property. Optoelectronic property. Yeah.
Well, the optoelectronic property is nothing but the characteristics that we got from the study of quantum mechanical study of the electronic and optical properties of any material. So it is actually based on the quantum mechanical effects of light on electronic material, especially in semiconductors.
Okay, in semiconductors, no, or switches. There
Yes.
can be some switches also, no?
Yes, sir. Yes, sir.
Okay, thank you very much.
Thank you, sir.
Okay, so may I correct the definition of luminescence?
Yeah.
So luminescence means that excitation wavelength and emission wavelength, that the emission wavelength is on a higher side than the excitation wavelength. Or from the frequency point of view, the emission frequency is lower than the excitation frequency. And the defined type means that it can be the photoexcitation, the PL, no? Sorry, that photoluminescence, it can be chemiluminescence, it can be cathodoluminescence, it can be thermoluminescence, and so on. So you have to excite the molecule by defined methods like photo-excitation, chemical reaction, and so on, but emission has to be on a higher wavelength.
Always in a higher wavelength side.
Yes, it is on a higher wavelength side.
That is very good. Yeah, it will be helpful to the students. So let us move to the another 52 cmps. This is, are you available? That Subendu Das?
Yes, sir. Yes, sir.
Okay. So that the
Yes, sir. I am.
Okay. Just what is double perovskite compound? Double perovskite compound.
Yes, sir. Actually, basically perovskites. Yes, sir. Basically, perovskites are of the type like AdX3 or AdO3, where A and B are actually cations, and X or O is the anion part. And A we take from the rare earth element or alkyl earth element, and B is transitional element. Now, if we double this cell, that is, if we get two cells, then it becomes A2B2O6. So in this position, in A and B position, actually we can replace elements like A dash BB prime O6 or A2BB prime O6 or X6 like that. By doing this, actually we can vary the physical characteristics of this compound. And since it is double the unit of a single perovskite, so it is actually double perovskite. And there are so many stochastic structures like A2B2O6, A2BB prime O6, A prime B prime O6. And even it is possible to make hybrid perovskite by substituting a organic radical in place of an cationic, just like CH3NSP. So actually double the structure of perovskite compounds is single perovskite compound is actually double perovskite. So there is a scope of lots of variety and replacement in the element.
Okay, there is second question. It is asked by Ria Bian. So that at the beginning of introduction part, okay, at the beginning of introduction part, you used the word quantum confinement effect. What it is?
Right?
Quantum confinement effect.
Sorry, please.
Yeah. What
I didn't get your question, sir.
Yeah.
Quantum.
What is quantum confinement effect?
Quantum confinement effect, actually it may be a variety of, in case of variety of cases, sir. Actually, we are making quantum mechanical calculations through solving the through DFT calculations. So for electronic structures, we make some assumptions, approximations. So in case of our calculations, actually we consider only the valence electrons, and the core and core electrons and nucleus are actually we do some approximations like pseudo potential approximation. In our case, it is full potential linear augmented approximation, LDL like this. So this is a kind of quantum mechanical.
Okay, next question. So in XRD pattern of zinc ZNS, so there is two more peaks, 220 and 311. There are two peaks approximately at 48 degree and 56 degree. Okay, but you consider only one peak, 111.
Sir, I didn't get your question, sir.
Yeah, which you get at 29 degree. Why?
Sorry, sir, I didn't get your question, sir. Regarding what, sir?
You have got another peaks at 111. Okay, plan. With at angle of 29 degree.
In which sir, in which graph, sir?
111. 111 lines. Okay. So you have got at 29 degree. Why?
Sorry, sir, I couldn't understand. Regarding which graph or actually graphical presentation question related, I am not understanding the part.
This is XRD pattern.
Sir?
XRD pattern of ZNS.
No, sir, I don't have any XRD pattern, sir, in my presentation. Actually, we are doing very theoretical part, so.
Maybe it is with different posters. Maybe. Thank you very much.
Yes, sir. Yes. Okay, thank you, sir.
Okay. Then this is 53 CMPS. The 53 is already over now. Okay, fine. So 53 is over. Is it 53? Oh, 53 is different one. Okay, fine. So this is 56 CMPS. 56, are you available?
Yes, sir.
This is A. Deepak Sharma.
Yes, sir.
Okay. Why is EDS spectra you are getting with many elements? EDS spectra, there are many elements in the spectra.
Okay, sir. Sir, there are the constituent elements present. Because
you are getting some kind of impurity also.
Sir, I have deposited my film over the glass substrate, so I also get silicon carbon. That's for the glass substrate, sir.
Oh, the carbon will be always there, no?
Yeah, yes, sir. And iron is for we have coated to measure the EDX, so that's why iron is appearing. And for elemental ones are ZD, Mn, and Fe, Bi, the bismuth, and oxygen. That's are my compounds.
Oh, that's why those things are. It is done where you have carried out the setup.
Yeah, this is done in IIT Kanpur, sir.
Oh, IIT Kanpur. So we don't have in Assam or it's nearby states these facilities.
Sir, I have been. I think it is available in Guwahati University, sir. But
okay,
for
very
this
good. So anyway, you can cross check once again if you want. Okay, thank you very much.
Yes, sir.
Now I'll move to 57 CMPS. This is Alok Kumar Das. Are you available? Dibrugad University.
Yes, sir. I am available, sir.
That one questions.
Yes, sir.
What do you think that the band gap is increased with deposition time? Why?
Sir, the band gap is increasing with deposition time because of the increase in crystallite size because of the increase of temperature.
Temperature is one of the parameter?
Yes, temperature is one of the parameter in my deposition process.
Or there will be some more number of say interaction or reaction.
Actually, I have carried out the deposition process. Actually, I have increased the deposition time consecutively. So as the deposition time also increases, the crystallite size will also increase, and that is actually the reason of the changes in the band gap.
So it is feasible in other materials also, or only it is some exceptional case?
No, it is feasible in other materials also. We have actually used the ternary compound CDSSE here in this case. I have also carried out the same. I have also got the same results for CDZNT also, cadmium zinc telluride. The same results I have obtained.
Okay, another question.
Yes,
That is asked by Nirmalya Dev. So the question is, so you have discussed about the effect of deposition time so far, huh?
Yes, sir.
But can you explain the role of complexing agents and effects of chemical bath solution pH in chemical bath deposition?
So the role of complexing agent in this deposition process is to the slow down the reaction. Actually, there are three precursor ions in our deposition process: cadmium 2 positive, sulfur 2 positive, and sulfur 2 negative, and selenium 2 negative. So the reaction between these three ions is goes on decreasing, and the rate of reaction goes on decreasing as we increase the concentration of the complexing agent in the chemical bath beaker. So that's why, sir.
Okay, maybe that Nirmala is benefited. Okay, thank you very much. Now
Okay,
I'll
thank you,
move
sir.
to 58 CMPS. It is Marla Prasanti, GITAM. Are you available, Marla?
Good morning, sir. Yes, sir, I'm available, sir.
Okay, very good morning. So I have a question. So can you mention some application of nonlinear properties?
Sure, nonlinear optical properties are generally used for the electronic devices like different electronic devices like keys, just like magnetic mouses and different liquid crystalline displays. We can use nonlinear optical devices, sir.
Oh, is it? Okay, okay. Then switches mean electronic switch, or you can also
Electronic. No,
use
no, sir. Electronic switches, sir.
Okay. You also mentioned about some soft molecules. What are they? Soft molecules?
Actually, here we consider the 4-bromobenzyaldehyde and 4-bromo-2-fluorobenzyaldehydes. These two molecules are soft molecules because they are having some phase transitions in the different temperature variations. If we follow the literature for those molecules, later.
It also changes its color.
Yes, sir. They have multicolored smectic phases also seen in this molecule, sir.
Oh, is it? Okay. Okay. Nice to know these things. Yeah. Thank you very much.
Thank you, sir.
So next we'll move to this is now 63 CMPS. Because one or two posters I could not get access, so those are not uploaded probably. So let us move to 63 CMPS. So this is Ripa Paul. Are you available, Ripa?
Yes, sir. Yes, sir.
Okay. So one of the question is surface pressure increase with time. Why surface pressure is increased with time?
Yes.
Yeah. Can you explain?
The coagulation so there is a increase in surface pressure of the
Yeah, your voice is not it's audible. Yeah, but it is getting cut.
Hello.
Yeah, now audible. Yeah, explain.
Am I audible?
Yeah, fine. Go ahead, please.
Okay. I biomembrane for with a so it is UPC made. So in this case is with
Okay, your voice is getting cut. I don't know somehow that maybe that other persons listen it. So anyway, thank you. Because voice is getting cut, I am not able to listen. Yeah. Anyway, let us move to next one. This is 64 CMPS. Farhana Yasmin, are you available, Farhana?
Yes, sir. Hello. I am available.
Yeah, good afternoon. Yeah. So that
Yes,
one
sir.
of the question is why neuromorphic computing is so important for memory devices.
Yeah, definitely. Neuromorphic computing is nowadays it's a very more a significant memory device nowadays. And the main thing we have to look at is that it can operate at very low power, and it can even store a huge amount of data, and moreover it can perform error-free calculation. So definitely we could say it is more important nowadays, and even the most important thing is that it can mimic human brain. That is the most specialty in neuromorphic computing that we are going to perform in our lab.
Any trial kind of experiment is given?
Actually, this is my initial stage. Just few days ago, I have started and just going through several, experiments are going through several samples. So I haven't reached up to that neuromorphic computing, but it will take time for that.
Okay, in the same way, another question is asked to you. This is by Sagar Hussain.
Okay.
So, what are the advantages of neuromorphic computing?
Actually, the advantages, if you could say, the previously whatever the question he have asked, almost the same question it is.
Yeah,
So there's no extra and specific thing I have to mention. It can operate at very low power, and definitely it can store huge amount of data that nowadays it is going to be possible. And
so this is one of the emerging field. Probably it will come, and we'll also look for it.
Yeah.
So physically something will be available to our society also. Very soon.
Okay.
Okay. Thank you very much.
Okay. Welcome, sir.
Okay. Then let me see. Let me also go to another one. This is another question on 50 CMPS. Are you available 50 CMPS again? Okay, anyway, I already asked few questions to her. So this is another question on 53 CMPS. No, don't come. Yeah. Okay. This is Deepak Sharma, na? So,
Yes.
Which number of your poster?
56, sir.
56, na? Okay, 56, na? So the last question is 56, na? Oh no, let me start nuclear and analysis, huh? So if I get that question, I will come back to you once again. Yeah.
Okay, sure.
This is 3 NBHEP, nuclear physics and analysis physics. This is Neelam Shetty. Are you available, Neelam?
Yes, sir. I'm available,
okay,
sir.
Okay, Neelam. You are from Tripura or what?
No, sir.
Okay, fine. So in your poster, you have done some Raman studies, Raman spectroscopy, na?
Yeah, yes, sir. Yes, sir.
How it is important?
Sir, actually, Raman study is basically implemented to study the vibrational modes, to study the rotational or determine different vibrational modes of molecule, its frequency mode, to study the so that we can get an in-depth study of that molecule in its future perspectives. So in this present paper, I have studied the interaction between the L-threonine and DMF, which is further implemented in various drug production or also in pesticide production. So to study this uses, I have used a Raman spectroscopic study to.
It is basically experimental studies, right?
Yes, sir. Basically, it is experimental study.
Okay, you are getting secondary excitations and everything, those kind of
Yes,
things.
yes, sir.
Okay,
And I also compared the experimental data with the computational modes using BFT and IFPCM model.
So you are doing some simulation work also?
Yes, sir. Simulation work also I have done.
Okay, good studies. Okay, thank you very much. So now we're moving to 5 NPHCP. This is Sangeeta Dey. Are you available, Sangeeta?
Yes, sir, I'm available.
Okay. My question to you is that what is the neutrino flux on the Earth at present?
What is the neutrino flux?
On Earth.
Neutrino flux, till now we have detected the neutrino oscillation. I have no idea what is the exact number.
Yeah, it is a general kind of question. So
Yeah.
generally it billions, it's
Yeah, it's
100,
billion.
yeah,
Yeah,
billions.
it's like next to photon. If it is available, it is for neutrino only, as it is not yet. It is very weakly interacting, so it is very difficult to detect neutrino. So actually, after a photon, if we get something that is neutrino.
What is your opinion that it is deviated from standard model?
Actually, it is deviated. In standard model, neutrino is actually massless. So we have to go beyond standard model, because in neutrino oscillations, we have found that neutrino has a very small amount of mass. Until now, we only know the mass square differences, and we don't know actually what is the absolute value of the mass of neutrino. So for that, we need to go beyond standard model to study the mass of the neutrino.
Okay. So have you heard about superconductor?
Yes. Superconductor, it is the experimental setup. Like it was the experiment which was done to detect neutrino, and from there only we got to know about the results of neutrino oscillations.
Okay. Okay. Nice to know. Yeah. Thank you very much.
Okay. Thank you, sir.
Yeah. Now move to that 7 NPHCP. It's Sapan Gayatri Devi.
Yes, sir. I'm present, sir.
Okay. Very good. Nice to know you.
Yeah,
Okay.
thank you, sir.
My question is, do you mention any phenomenological application of neutrino's double beta decay?
Sorry, could you please repeat it again?
Do you have any mention on phenomenological application?
Actually, I don't deal with the phonological approach, so I think I cannot answer that one.
Okay, but you mentioned at the like there is also some scope like this, no?
Yeah, there is actually scope, but my area, I do not discuss that part. I just my area is like I just derive the Hawking temperature by using the on account of quantum gravity effect.
Okay, this much only you have done. Okay.
Yes. And actually, after getting the temperature, we can also calculate the specific heat as well. And we can also calculate the entropy. This article is under review, sir. So I didn't mention the entropy part and the specific heat part. That's why, sir.
Mainly thermodynamical parts you have seen, right?
Yes. My study is only the thermodynamical part.
Okay, this is because this is having a great horizon. You can also look some other parameters also. What I mentioned.
Yes. I could actually do that also, but I don't know. I just like the temperature calculation part, sir, so to say.
Okay, this is beginning. No problem. Physics is very vast, no? So
yeah,
you
it's
can
actually
only
very
do some part of
fast.
it.
Yeah.
No problem.
Yeah.
Okay, thank you very much.
Thank you, sir.
Okay, now moving to that 8 NPHEP. This is Animesh Burman.
Yes, sir, I am present.
Okay. So, Burman, that my question: why neutrino should have flavor symmetries? Without this, can anyone talk nuclear physics or not?
Means question I'm not getting clearly. Why neutrino?
Yeah, should have a flavor symmetries.
Yes, sir. Flavor symmetry should be there.
Yeah, why? Without this, nuclear physics can run or it can move ahead?
It is not possible, sir.
Yeah, that's fine. Yeah. So how many flavors you have?
Basically, three flavors is there, sir.
3.
Yes, sir.
Okay. So which one out of the 3 flavors? Which one is more feasible?
Sir, actually, it oscillates regularly. Means you cannot tell directly.
It oscillates.
Yes, sir.
But you cannot pinpoint that this one is more feasible over the other two.
Somewhere I got that means sir, it is something difficult, sir, tell directly. Means
That is,
different
you do not have experimental findings about it.
Yes, sir. Experimental findings means which flavor is coming more. You are asking that?
Yeah.
Sir, experimental setup means sometimes just like solar neutrino oscillation. Means,
That's not only now.
yes, sir.
Okay. Anyway, so this will be this will come probably with this is there is a fair panda facility, huh?
Yes,
Panda
sir.
facility, fair facility
Yes,
for
sir.
antiproton and ion research.
Yes,
So
sir.
their intensities and analysis is very high. So
Yes, sir.
there are probably some kind of questions, no, about hadron physics, no.
Yes,
So at one point, no, it is not started. It is undergoing. Okay.
Okay, sir.
So it might be some answers will come in few years. Yeah. Thank you
Yes.
very much.
Thank you, sir. Thank you.
This is moving to 9 NPHCP. This is Nilab Jyoti Hazarika. Nilab, are you available?
Yes, sir. I'm present. Am I audible, sir?
Okay, small question, huh? So
Yes, sir.
how important is the vacuum instability to find out the mass of Higgs boson?
Okay. So in particle physics or in field theory, we actually calculate the mass of Higgs boson or any particle.
Yeah.
Yes. So if I say assume the mass of the Higgs is say m, then it is directly actually proportional to the vacuum of the vacuum expectation value, VAV, or we say it as VAV, or say I can write as say mh is equal to lambda h into v.
Yeah.
So if I can calculate the vacuum expectation value, or say vacuum,
yeah,
and the coupling constant lambda, then I can calculate the mass of the Higgs.
How much you have got? Like if it is vacuum is stable or it is not stable, like is there any demarcation?
Okay, so in case of the standard model, we take the vacuum expectation value or VAV to be 246 GeV.
246.
Yeah. So and at the end, and in 2012, it has been already established or found in LHC that the mass of the Higgs boson is around 125 GeV.
Yeah, that is my body. So the
Okay.
is known as 125, but you mentioned at 250 something like that.
Yes, no, that is the vacuum. That also we can say name it as a ground state. Ground state.
Oh, it is ground
So
state.
vacuum is nothing but the ground state. Yes.
Okay. That was my
So for standard model it is 246 GeV. But if we say extrapolate our theory, say if we extrapolate our theory to say higher energies, then what we get is that that the vacuum. So in theory the vacuum should be one. We should get one value, right? But when we extrapolate our theories to say higher energies, then we get another value of vacuum, say around at least 10 to the power 11 GeV. So that means whatever vacuum we are considering here, that is not unique. So we have another vacuum or say ground state. So whatever in standard model, whatever wave we are getting, or say ground state, wave or vacuum, that is metastable state.
Okay. Anyway, so we can talk later on also, no?
Yes, sir.
Okay. Thank you.
Thank you, sir. Thank you, sir.
Moving to 10 NPHCP. This is K. Muhammad Murtwaja, Tamil Nadu.
Yes, sir. Yeah, I'm audible. Good morning, sir.
Oh, good morning. Yeah. So you have extracted the potassium 40, uranium 230, and thorium 232. Is that it?
Yes, sir. Yes.
Yeah. So what are the from where these sources are coming? Potassium 40.
The potassium mainly it can to the fertilizers, sir, which is higher than values. It can be due to the producers of fertilizers.
So it is coming from
the
atmosphere.
more than we can consider it from fertilizers, sir. Whereas uranium minerals are having their own radioactivity based on
They're radioactive now.
Yes, sir.
Even by boron also we have the fraction of potassium. Do you know it?
Yes, sir. Yeah, yes, sir. But the limit of potassium in periods are more.
You are not getting radon in that case. Why I am worrying? You are not getting any radon peak there?
No, sir, conversion from radon to the uranium source. No,
Okay, you are getting some peak?
sir, sorry.
Are you getting some radon peak?
No, sir. I have calculated the no radon peak.
Okay. Anyway, that your audio is very low. I don't know. Yeah. Anyway, thank you very much. Huh?
Hello, sir. Hello, sir. This is Sapam Gayatri. Just now, you just asked the question to me, but I think my number is 6 NP. I think you have said 7 NP.
Maybe maybe there is. So okay, it is written. It acts by Bididnath on 6 and 6 and PHEP. Is it this one?
Yeah, that's mine. Yeah, I think you should ask 7 NP as well, because I think he said in the group, like actually sir announced his name and like his number, but like you just gave me by the question.
Anyway. So I have also a question. It is asked by Bididnath. So can you answer this one? Why Hawking radiation has never been observed?
Sir, it's actually a theoretical process. So I can say that by calculation only, we could say there is a temperature of a black hole. That much knowledge I can give you.
Oh, is it? Okay. Another question also asked by the Bididnath. Why does steady conversion of quantum vacuum fluctuations into pairs of particles held on black hole?
Sir, that is because in my work we consider in the quantum level. So, I mean, like we consider quantum gravity effect. So what happens in quantum gravity effect is that near the horizon of the black hole, there is a vacuum fluctuation occur there. So whatever study that we do in my work is based on quantum physics. So it's how can I? It's a quantum fluctuation process. That's why.
It's all right. It's all right. So it will be known because it is whole things are evolving. So, but
Yes.
one day that will get more answer. Okay. Thank you very much.
Yes, sir. Sir, one more thing. There is a confusion. Mine is 6P and the 7P person has not answered, I think. So I think you have to remind him or her. I don't know who is that person.
Okay, I don't know who is he. Okay, I will get back. Yeah.
Okay, sir.
Thank you.
Sir.
So
Thank you,
let me move to 15 NPHCP. This is Manipur University. Kuman Them and Helen Sena Devi. Are you available? 15 NPHCP. If not available, we can move next one. This is 16 NPHCP. Amadas available? Amadas?
Yes, sir. Yes, sir. I am available.
Just let me ask one question. So,
Yes, sir.
So you have taken only 2 loosely bound systems.
Yes,
Okay.
sir.
Why
Yes,
you have
sir.
not considered other loosely bound systems? There are many loosely bound systems. Why not consider others?
The other system have been done in the previous very few papers, but these systems I don't found any experimental fusion suppression. So I have considered this. These are the new systems. So this I have considered.
But there are some papers also, no, loosely bounded Biennial 9.
Yes, sir. But their papers I have included, but I will give in papers. This is the for.
Yeah, that's so it is. It's considered like some kind of less.
Yes. I will consider in my paper.
Okay. Anyway, thank you.
Okay, sir. Okay, sir.
Okay. Then next goes to Novendo. Then 17 NPHCP. Novendo, are you available? Novendo Kumar Dev. Novendo available?
Hello, sir. Sir, I think he is not allowed to enter in the Google Meet. I think there is some kind of problem.
Okay, I can now ask Harun. Harun. So why
Yeah, yes.
calcium 40
Yes, sir. Yes,
target
I am
is
here.
important? Why calcium 40 target is
Sir, this
important?
is sir. This is a doubly magic nuclei because neutron number and proton numbers are equal, and it is very much stable. So it is therefore we have chosen this 40 calcium target to study the scattering processes.
And is there any effect of breakup on 6 lithium?
Sir, in this paper, we have not studied about the breakup here. We have just considered the elastic processes, and we are planning to do actually the other transfer processes also later on. Do some
Okay, now I got it. So okay, thank you very much. So moving to
Okay, thank you.
now, this is 19 MP HCP. This is Maibam Ricky Devi. Maibam Ricky.
Good afternoon, sir.
Good afternoon. Okay. So so you mentioned something about the second and third generation neutrinos. What are they? Can you explain a little bit?
Second and third generation neutrinos. So we know that neutrinos has got 3 families. So it varies according to the mass of the flavors of the neutrinos. So second and third generation that means only the second family and the third family.
Can you name few of them?
Muon neutrino and tau neutrino.
Muon and tau.
Yes.
Okay. Okay. Anyway, so that let me also check. Is there any question from your? This is 19. This is 17 MPHCP here. No. Okay. 19. Okay. Thank you, Ricky.
Thank you, sir.
Okay. Next question. 20 MPHCP. This is Abdul Aziz, Assam University. Abdul, are you available?
Good afternoon, sir. Yes, available.
Good afternoon. Good afternoon. So, I'm going fast or what? Or it is?
Yes.
I'm going fast.
Oh.
Okay, little.
Okay.
Anyway, so can you emphasize the use of this coronal potential in your work? This is
Yeah.
It is having 2 parts. One is like something like Coulombic part, and another one is this is valid for quarks and hadrons. So
Yeah,
it is
yeah.
summation of the 2. Is it?
Yeah, yeah.
Yeah. Can you explain? Yeah.
So it is due to the confinement and the asymptotic property of the quark, we are using the coronal potential.
Means it means that quarks also sometimes having short range and long range force.
Long range. Yeah, yeah.
Or always long range.
No. This is in the 2. We are using the 2 cases.
Yeah.
Here in the long and short range case. So BR, there is confinement parameter is there, and also the asymptotic fitting, the Colombian part is also there.
Colombian part also there. Okay, long range also there. Okay.
Yeah.
And ultimately, you have done some perturbation theory or different?
No, we are just developing the Schrodinger equation and trying to find out the masses, and which we compare with the other PDR masses.
Okay. How much work is developed? Like.
Yes, we have developed that is in our evaluation. We have solved the problem, and when we found the masses, they are very near to the our masses, and the particle data group masses are very near to each other.
So you have published or not?
Yes, we are going to publish this one very soon.
Okay. Anyway, so I have seen this one. I have seen this coronal potential in our university. Some groups are doing.
Yeah. Yes.
So from very long, it is going the same kind of potential.
Yeah.
So do you have another writer? This is from Gujarat. It is P.C. Sodhuri.
What I cannot understand.
He is also starting this kind of. Yeah.
Oh, okay.
Yeah, he's also he's also doing this sort of. Yeah. He came to our department once, Guwahati University, and delivered it up. Anyway, nice work.
Okay, thank
you very much. Yeah. So this is 21 MPHCP.
This is Victoria Puyam, Manipur University.
Yes, sir.
Yeah. Okay, good afternoon.
Good afternoon, sir.
Okay, and small question. So why prediction of theta 13 is very less? That angle is very less compared to the other two. That angle is coming out 8.43 degree.
Yeah.
Is there any reason?
Yeah. Actually, these thetas are the mixing angles.
Yeah.
So, the theta 13 actually, previously we thought that theta 13 is 0 or something there, but due to the current experimental data, we find that it is found to be in a very small, that is about 8.15 approximately like that.
Okay. Okay. Then and why that phase delta is obtained at the 191.4 degree instead of 180 degree?
Excuse me?
Generally phase angle is at say it is backward 180 degrees or similar, but you are getting it at 191.4 degree.
Actually, sir, according to the global fit data, the CP violation phase delta can be found between. I actually give the global fit data. There you can find that it could the best fit is at 194. So I think it's very close to that. So
you have got 191.4, right?
Yeah. Yeah.
Okay, maybe because of the some correction factor. So instead of 180, it is coming 194, whatever you mentioned. So you are getting 191. It's all right, no problem. But because for generosity, I have asked these questions. Yeah, thank you very much. Okay, then coming to 22 NPHP. This is Dipti Montoneu.
Yes, sir.
It is Neris, no?
Yes, sir.
Okay, during your talk, you have mentioned a lot about Parton and also the mention about Hera data, isn't it?
Yes.
Yeah, can you, because as a layman, no, because it is a mixed audience, no, what is Parton and from where the Hera data you are getting? Can you explain this too?
Okay, sir. Thank you. Parton is nothing but basically part of protons. That means the constituents of protons, nothing but quarks and gluon. Firstly, which is named by Richard Feynman. This is about the partons. Now, yes, actually, in this paper, I mentioned different types of data sets which are coming from LSC PDF library, which are NNPDF, CT10, and MSTW. It means these all are actually based on LSC PDF library.
Okay.
So
that is available online, no?
Yes, sir. Yes, sir.
Yeah, with Hera data, we come across anyway. So this your data is matching with Hera, with how much percentage?
Yes, sir. In this paper, I have only studied about the comparative studies of gluon distributions inside the proton. Okay. So that's why the plots are actually which establish the theoretical ones actually, which.
Okay. Anyway, okay. This is so you have to do some more work in this direction, no? Isn't it?
Yes, sir. Yes, sir. Yes, sir.
Okay. Anyway, thank you very much.
Thank you, sir.
So moving to 23 NPHP, this is Levina Sharma, Tezpur University.
Yes, sir. I'm available.
Okay.
Actually, I have to log in through another account. I could not log in from my account.
You have logged in Jatin Gogoi's one.
Yes, sir.
Okay, no problem. So little query. What is the influence of 1,0 texture on baryogenesis in one and two sentences?
Yes, actually, sir, texture 0, 1 texture 0 means one of the element of the Yukawa coupling matrix is generated to be 0. So we just see that for different structures, how we can study the phenomenology in scotogenic models. So in my work, we see that for 1,0 texture in the 2,2 position, we get the desired baryogenesis, which is given by Planck, and also the neutronless double beta decay, which sets a upper bound to the effective mass of the active neutrinos, that is also simultaneously satisfied for this structure of recover coupling in our work.
Okay, it is purely theoretical work.
Yes, it's phenomenological work, sir.
Phenomenological. Okay, fine.
Yes.
Okay, thank you very much. Okay.
Thank you, sir.
Okay, then 25 NBHCP. This is T Thuang Thang Sangha. This is Mizoram University. Are you available? Thuang Thang Sangha. Are you available? 25 NBHCP. Okay, no problem. We'll move to next one. This is 26 NPHCP. In the same array, there are two papers by the same author. So you are not available, okay? This is T. Thuam Thanga Sa, Mizoram University. Okay, no problem. So moving to that, this is 27 NPHCP, Dr. Mahmuda Begum. Are you
Yes,
available?
sir.
Mahmuda?
Yes, sir, I am available.
Okay, fine. There is a small question.
Yes,
So
sir.
we know that that equipotential, isn't it?
Yeah.
So
Yeah. Wave
equipotential,
potential.
yeah, equipotential mainly that it validates actions of some say neutron, proton, and similar kind of things, no pions.
Yes.
But
Yes, sir.
it is also used in plasma physics. How it is correlated? Can you explain a bit?
Yeah, in plasma physics, there are ions, electrons, then dust particles. And in my work, I have developed a simulation code. And in that code, the Yukawa potential is in my limit. I have used periodic boundary condition. In that
Okay.
limit,
What?
the Yukawa potential is valid.
Okay.
So
What are the conditions? Say minimum. Can
conditions.
yeah, conditions.
Yeah, there are some limit interparticle distance, then
Okay.
dust charge. There are some definite values. Within that limit, we can use the Yukawa potential.
I like that within device pair or similar. Like in plasma physics, there is a device pair, isn't it?
Yeah, device pair.
Okay.
Yeah,
That,
lambda d is the Debye length. Yeah, in Yukawa potential, we have used the here lambda d, that is the Debye length.
okay, Debye length. Okay.
Yeah.
So within that periphery, it will interact. Is it right?
Yes, sir. Yes, sir.
Okay. Anyway, it is new things. So I have heard.
Yeah.
Anyway, good work.
Yes. Oh,
Thank you.
okay.
Thank you.
Thank you, sir. Thank you.
No, don't come. John. Okay, moving to 1C1. This is Deepika Das, Tripura University. Deepika Das, are you available, Deepika? Deepika Das. Am I audible now?
Sir, her mic is not working properly, and she has several times disconnected from the Google Meet. That's why she is facing some
Deepika,
problem.
no, Deepika. Okay,
No,
fine.
Deepa Das, it is.
Oh, Deepa Das, no? Okay,
Yeah,
okay.
1 and 2, both papers.
Okay, let me go through some of the questions asked by the participants. So this is number 1 is asked that it is on 6 NPHCP. Then there is another one on 57 CMPS. 57 CMPS available?
Hello, sir. I am available.
Yeah, there is a question asked by Sangeeta Sakrabarty. Huh? So what is
Yes, sir.
Urbus energy? Because she has asked, what is Urbus energy? Can you explain?
Sir, Urbeck energy is the actually it's a parameter which is, sir, Urbeck energy is a parameter films which we have deposited. So it is actually a measure of the defects in our deposited films. Urbac energy.
or deposited fields. Okay.
Yes, sir. So we can
It is
get the
induced energy, or it is.
So no, it is not the induced energy, but we can actually measure the Urbac energy from the band gap of the materials.
Okay, from the band gap of that. So okay, you have
Yes,
made some material, then out of that, you
Yes,
are
sir.
getting band gap energy as well as that.
We have first we have calculated the band gap of the deposited films from the transmission spectra, and from the band gap we have calculated the Urbac energy, which is a measure of the disorder in the deposited films.
Okay, anyway, that in the same way, she is also asked the decrease in band gap and band gap increases with deposition. As I asked similar question,
yes,
what is the inference of this statement?
Sir, can you please repeat the question?
That the band gap increases with deposition time. Decrease in band gap increases with deposition time.
So this is as I have mentioned earlier also, because this is because of the increase in the crystallite size. We have got the changes in the band gap energy.
Okay, okay, maybe because I'm not expert in the condensed matter physics. Anyway, thank you. Then there is a question on 17 NPHCP. 17 NPHCP, are you available?
Sir.
Okay, it is asked by. Okay, it is asked by Dhananjan Rastogi.
Okay, sir, I joined from different account.
Okay, no problem, no problem. Just that physics is
Okay, okay, sir.
independent now.
Okay.
Independent of account. Only that.
Okay, sir. Last time also you have asked one question, but then I have heard it from YouTube, but then I could not answer it.
Okay, I'm going through the
Okay.
questions which are asked by participants now. Okay.
Okay.
What is
Okay, sir.
thermal evaporation technique? Why you use thermal evaporation technique in your measurement?
Okay, thermal evaporation technique is a physical vapor evaporation setup. I mean physical vapor evaporation technique, and this is one of the very good way of preparing the thin film. There is another way. It is something known as sputtering method, but then in the target lab facility that we have, this setup is available. So this is the reason why we use this.
Okay, another question. So I asked to you. So let me also mention that question. Huh?
Yes, sir. Yes, sir.
Let me see. So this is okay. This is November now. Why samarium and
Yes, sir.
niobium target is having larger thickness? You have mentioned there 200 to 700 microgram per cm square. Isn't it?
Yes, sir. Yes, sir.
Why it is having more thicknesses?
Because it is the requirement of the experiment. Because this is the requirement of the experiment.
Is it
Here we have to develop the activities. Yes, sir.
It is for fusion measurement.
No, not fusion measurement. It is to develop the activities.
Only
There
develop the
to develop the
activities.
activities, and then we have to what we say. We have to find out the offline measurement afterwards.
Okay, it is activities in terms of gamma rays or surface particle.
Yes. Gamma, especially gamma.
Especially gamma.
Hmm.
Okay,
It's something known as forward recoil distribution.
Forward recoil distribution. Okay.
Hmm.
So it will detect also alphas also.
Alphas also, and some what we say that small lifetime elements. Some elements of the small lifetime.
Okay, small having okay. Small
After the evaporations of some particles, let's say neutron or gamma, which may be a prompt particle evaporation. After that, whatever things are being developed there in the form of residues, we have to detect those. So this is the purpose, and for this we need a substantial thickness. We cannot prepare the thin, thin foil.
Okay. Anyway, thank you very much. Huh?
Okay, sir.
So this is next question on 5 NPHCP. Are you available? 5 NP HEP participants? 5 NP HEP?
Hello, yes, sir.
Okay, the question is asked by that Asmita Saha. What is Tobot-Nielsen mechanism?
Okay, actually, it is a mechanism which is used to determine the hierarchy of neutrino mass matrix. Actually, we don't till now we don't know which is greater. Like there are three types of hierarchy: normal hierarchy, inverted hierarchy, and degeneracy. So this kind of mechanism, it helps us to determine like what is the actual hierarchy of neutrino masses. That is whether M1 is greater than M2 is greater than M3, or whether it is normal, inverted or degenerate. So in this Fogg-Nelson mechanism introduces a horizontal symmetry, and there is a small parameter which characterizes the breaking of the symmetry and is used to accommodate the parameter of masses and mixing which is observed there. So for this reason, it is usually considered as a useful phenomena to explain the hierarchy of the neutrino mass matrix or neutrino masses.
Okay, then thank you very much.
Okay,
so next 50 cmps. 50 cmps available?
Yes, sir.
Okay, asked by this is Marilina Das, participants. So question is, why did you study only the optical characteristics and electronic characteristics of gallium arsenide, GaAs? Why did not, in the same question, why did not you study the magnetic characteristics as well?
So first of all, I haven't studied gallium arsenide or the optoelectronic properties of gallium arsenide. It's just lattice match to gallium arsenide. So I have studied the optoelectronic properties of this said quaternary alloy, and my main target was to find out the optoelectronic characteristics. So though that zinc has the 3D, the orbital, so it may show the magnetic property as well. But I haven't studied yet. Maybe later I will study.
Maybe later on you can continue, no?
Yeah, yes, sir, yes.
Okay, thank you very much. Good
Thank you,
answer. Okay. Then 53 cmps, it is asked by Autonomous Sarkar. 53 cmps available? 53 cmps, 53 cmps available? Okay, no problem, we can skip. Then it is 9 NPHCP. 9 NPHCP available?
Yes, sir.
Okay, that question is asked by Raktim Das. What is
Yes, sir.
what is photogenic model?
Okay. So this model was actually proposed by Ernest Ma in 2006. So as I've already mentioned in the poster, so it is a extension of standard model with one inner doublet, and one singlet scalar, or say one singlet scalar, and 3 copies of fermions. So it is a dark matter model.
Okay. It is dark matter model, no?
Yes, sir.
Okay, that the Raktim Das will get this one. If he wants more, no, he can contact you. Okay.
Yes, sir.
Okay, thank you very much. So then another question on 2NP-HCP. 2NP-HCP, yeah. Are you available?
Yes, sir.
Okay, that question is asked by Shubham Asarji.
Okay,
So
sir.
why standard model cannot explain dark matter phenomenology and lepton flavor violating processes?
Mainly in standard model, we do not have any candidates for particle candidates for dark matter, so that we can explain the phenomenology of dark matter. In standard model, we do not have explanation for lepton flavor violation, as these processes are highly suppressed in standard model.
Is it? So generally, my always there is a question in my mind always that there is a called it is theory of everything and it is standard model. So is there
Yes,
any in between also like convenient model?
What, sir?
So we know that there is a standard model.
Yes, sir.
And I have also got someone is telling a theory of everything. I mean, everything they will cover. So there might be some other model which is known as convenient model. Isn't it? What is your opinion on this?
Theory of everything.
Yeah.
Theory of everything it is a theoretical concept that we can unify all three fundamental forces, but it is not till now it is not feasible theoretically.
Theoretically or experimentally also?
Experimentally also, because of the gravitational forces is not unified with other three forces.
Yeah. So it is a big question mark now. 100 times important question. Okay. Anyway, thank you very much.
Thank you, sir.
Okay. Then another question. It is on 7 CI. So CI are is that Deepa is present now? Deepa?
7 CI is mine. My name is
7
Manthan
CI
Ghosh.
okay. Let me ask you a question. Yeah. Question is asked by Sukarna Bhattacharya. What is the difference between ASE noise, phase noise, and dispersion?
Okay, the AC noise is generated for the whenever a signal is going through a fiber optic, then AC noise is named that symmetric amplified symmetric noise. So whenever
symmetric noise. Okay. Yeah.
And it is generated randomly, but the dispersion is depending upon the length of the fiber cable. The cable, whenever the cable distance is high, the dispersion will be high.
Yeah, cable is fairly long, then that
dispersion will be high. Yes, the dispersion will be high.
It means that current will move through the surface and it will be deviated, right?
Yes.
Okay. So this is known as what?
Dispersion.
Okay, fine. It is phase noise or it is different? Phase noise?
No, it is different. Phase noise is different. Phase noise is whenever the signal is going in the output, the amplitude will be same, but the phase will be different. This is the
but the dispersion by putting some kind of terminator can be overcome. That
dispersion simplifies like that. Whenever you send some signal, some of the signals is coming fast, some of the signals is coming late.
Yeah,
this is the main concept of the dispersion. It is because of the different wavelength has the different speed of light. That's why it's coming. Some of the information coming late, some of the information is coming fast.
Generally, if there are some late and it is fast now, so using that delay generator.
Yes.
So we can make some kind of gate kind of yeah. So it is sort out in that way now.
Yes.
Okay, that can be done in your setup also.
Yes, we have simulated these things in MATLAB.
Oh, MATLAB. You are simulating everything now.
Yes.
Okay.
The critical scenario is just simulated.
Okay, simulated. Okay, I also think about the experimental setup things.
No, it's just simulated.
Anyway. But generally in experimental setup now, we used to do that gate and delay generator.
Yes.
It will make some kind of gate, standard gate, then it will feedback to ADC, analog to digital converter. So accordingly, it is being collected everything. Okay, thank you very much.
Thank you, sir.
Okay, next is 4CI, poster 4CI. 4CI available? And 1CI is also not available now. 1 and 2CI. This is Deepa Das. Okay, 4CI. Not available now. Okay, anyway. So if participants have any questions, they can ask directly. So I have one.
Hello, sir.
Yeah.
Hello,
Hi.
sir.
Yeah.
Sir, I am 15 NP. Actually, my mic is not working, so
15.
15 NP.
15
Helensana, Manipur University.
Manipur, I asked some 15 now. Okay, let
Yeah.
me check something. I don't know. Let me ask 15 now.
Hello, sir.
15 NB now. Yeah, 15 NB just I asked. Okay, one by one. So 15 NB question is first question is 15 now. Why only you have chosen angles 40, 50, and 60 for your calculation?
Okay,
You have
that is for 10 beta. Yeah. Actually, I'm using 3 value of 10 beta. There is 10 beta. For 10 beta is equal to 40, 50, and 60. Actually, I want to know that actually I'm doing for inverted. I think I'm using inverted hierarchy. So I would like to I would like to collect in which 10 beta value there is that 10 beta 40, 50, 60 the output parameters of the neutrino, which one is stable. So in according to my convenience, so I take that 10 beta 40, 50, and 60. And 40 minimum 10 beta for 40, that is somewhat comfortable.
Somewhat more, not below 40 also.
Not below 40, there is quite insensitive, I think.
Insensitive. Okay. That was my curiosity. Why you have taken only 3 angles?
Accurate. Yeah. Yes.
Yeah. So
For
thank
my
you very much.
convenience.
Yeah, that
Okay,
was my
thank you, sir.
query. Yeah. Thank you very
Thank
much.
you, sir.
Yeah. Is there any question? Someone was asking.
Sir, I am 4CI. My
Of
mic
course,
was
yeah, you
not
have come.
working.
Okay, fine. Course, there is a question by Devasis Biswas. Question number
Okay.
1 is: can there be more one resonant frequency of the resonator at the same time? Continuing, if so, is there any chance of destructive interference in multiple round tips and output becomes 0? Can you get the question?
Sir, can you please repeat?
Okay, from the starting, can there be more than one resonant frequency of the resonator at the same time? Okay, this is first part.
Okay.
If so, is there any chance of destructive interference in multiple round tips and output becomes 0? Yeah, please.
Sir, most of the times there is only one resonant frequencies at the same time.
One resonant. Okay. At the same time, it can be multiple. It means, right?
Yeah.
Okay, and also sometimes there can be the destructive interference if multiple rounds comes.
Yes.
So you have seen those things, and then that output becomes 0 also sometimes, or it is maximum.
No, the output becomes 0.
Then it will be, if it is a destructive, then it is 0. If it is a constructive, then it will be maximum, isn't it?
Max. Yeah.
Okay, that is the query of that Devasis Biswas. Yeah. Okay, thank you very much.
Thank you, sir.
It will be useful for him. So with this, I have covered most of the questions.
Hello, sir.
Yeah.
Sir, my serial number is 7NPHEP, and
7.
sir, you called a different person in my serial number, so I was not. Yes. Is there any question on my?
Yeah, I don't know that question. Question was, do you mention any phenomenological application? Is it this one?
I don't think, sir. My
Maybe,
serial number is 7NPHEP.
maybe it is written in other places. Anyway, no problem. So for the time,
Okay,
I don't have question.
Okay, sir.
Later on we can
Thank
discuss
you.
more. Okay,
Thank
thank
you,
you
sir.
very much. Okay, Mr. Singh, thank you. Yeah. So, and if you have any questions to your colleague or to other participants, you can ask. Do you have any questions, participants? From my side, it's all right. Okay. So with this, if you do not have any question now with this, so I can I can conclude here, and I will over to Professor Hussein now. Yeah. Thank you very much. Yeah.
Thank you very much, Professor Kushal Kolita, for nicely conducting the session. And most interesting part is that you have covered almost all the posters and managed in such a way that at least one question for each and every poster. So this is very nice for the participants. So now we are moving towards lunch break. And after that, we have the last session of this conference as well as today. And this session will be starting at 2 p.m. And 2 p.m., there is a speaker from Israel, Professor Colin Price, and he will be speaking on very nice topic, lightning, biology, and evolution. So I request all of you to kindly come back before 2 o'clock and try to listen Professor Colin Price. So we will be joining here once again. Thank you very much. Have a nice lunch break. Thank you.
Thank you very much. Yeah, bye.
And Professor Kushal, I have one information for you. I have seen one email from Apri Dashamukko regarding the link for the PANE GB meeting. So you can circulate this same link to all GB members that with the time schedule, because time is there in the program. So all GB member may not have the program. So in your email, you can mention the timings of the meeting. Professor Kushal? Maybe left. Okay, I'll call.
Hello. Hello, sir.
Hi, Colin. This is Anirban. Can you hear me?
Yes. Hi, Anirban. How are you?
Yeah. Okay. We are just waiting for the session to start. So please wait for some time. We'll start on time.
Okay, great.
Okay. Thank you.
Dear participants, delegates, my dear students, I welcome you all once again to this technical session 6 on atmospheric physics, and this is the last session of the day as well as the conference. This session will be chaired by Dr. Anirban Guha, Department of Physics, Tripura University, and now I request Dr. Anirban to kindly chair the session. Dr. Guha, please.
Yeah, thank you, Dr. Hussain. I believe I am audible.
Yes.
Okay, thank you. Good afternoon, everyone. So, as the convener, Dr. Hussain mentioned that this is the last session of the Conference on Physics Academy of North-East. And in this session, we have two very eminent personalities. Professor Colin Price from Israel, who will be giving one invited talk, and also Professor Ramesh Chandra Tiwari from Department of Physics, Mizoram University. And following that, we have 7 contributory presentations, oral presentations. Those are related to atmospheric science and also multidisciplinary fields. So before I invite Professor Colin Price, who is online, I see, I would like to briefly go through his short biodata. So Professor Price is a professor presently at the Porter School of Environment and Earth Sciences at Tel Aviv University, Israel, and the head of the Department of Environmental Studies. He is an atmospheric physicist specializing in the Earth's weather and climate, with a focus on thunderstorm, climate change, and natural hazard. His recent research focus is on using atmospheric electricity to study natural hazards such as flash floods, hurricanes, earthquakes, and solar storms. He was born in Johannesburg, South Africa in 1962. After starting his university studies in South Africa, he transferred to Tel Aviv University in 1982, where he completed his BSc and MSc degrees in geophysics and atmospheric sciences. He received his PhD at Columbia University in New York in 1993, while working at NASA's Goddard Institute for Space Studies in New York. After completing a postdoctoral fellowship at the Lawrence Livermore National Laboratory in California, he returned to Israel and joined the faculty as a faculty of Tel Aviv University in 1995. He has published more than 150 scientific research papers and has a team of 15 graduate students and researchers working under his guidance on various scientific research projects. And I am also happy to announce to the participants that Professor Colin Price is intimately engaged in research collaboration with our department. We are having bilateral project with Israel Science Foundation, in which Professor Colin Price is the PI from the Israel side. And Professor Price also visited our university during a conference in 2019, and we were, always he is very helpful. So we are having active collaboration with Professor Price. So now I would request Professor Price to kindly share his screen and deliver talk on the topic lightning, biology, and evolution. Professor Price.
Thank you very much, Dr. Guha. Can you see my screen?
Yeah, it's coming. Yeah, we can see your screen. It's crystal clear. Please go ahead.
Great. So thank you very much for inviting me to give this talk today. And it may seem a somewhat strange title of lightning, biology, and evolution, but on purpose I wanted to make this a broad topic to interest the students, maybe to pique their interest in studying physics of the Earth and trying to solve some of the problems or the challenges we still have in understanding how our planet works, how the atmosphere works, and the system, the Earth system. So what we can see here, I hope you can see this animation of global lightning around the planet. This is data from satellites, from NASA satellites, an average of 5 years.
Professor Price, sorry to
Yes.
interrupt you. We are not seeing the animation. Maybe you are using the PowerPoint. Can you just play the animation separately?
Can you see the image?
We only see the first slide of the PowerPoint presentation.
Okay, let me see if I can go to the.
Now we can see that.
You can see this one with it.
I can see the animation. Yeah, please. Yeah, now it's okay.
Let's see if we can see the animation here. Okay, anyway, not to waste time, I'll just show you this image. You can see the image of the global lightning. And from what we understand from satellite data of lightning is that lightning is mainly over the continental regions. 90% of global lightning is over the land areas, and only about 10% over the oceans, even though oceans make up 70% of the planet. And the lightning moves basically with the sun, north and south of the equator. So lightning is mainly in the summer hemisphere. So northern hemisphere summer during June, July, August, and southern hemisphere summer during December, January, February. At any time, we have about 50 to 100 lightning discharges per second everywhere on the planet, anywhere on the planet. So as we're sitting here during this talk, there are about 50 to 100 discharges going off every second somewhere around the planet, and therefore there's continuous lightning activity around the planet. Now, when we talk of lightning discharges, we can think of this as an electrical antenna, a radio antenna. In order to get lightning, we need to generate up to close to 1 billion volts between the cloud base of the cloud and the surface of the Earth. I should point out that most of the lightning is within the cloud. About 75% of the lightning discharges are within the cloud between different charged regions. And only about 25% makes it to the ground, and that's the lightning we can actually see with our eyes. Now, inside the lightning channel, the temperatures can rise to up to 30,000 degrees. That's 5 times hotter than the surface of the sun for just a fraction of a second, microseconds. And this is what also produces the thunder we hear due to the shock wave, the rapid heating of the air around the channel, which expands outwards faster than the speed of sound. Some parameters of the lightning, we have about 20,000 amperes, which flow through the lightning channel from cloud to ground, bringing about 20 coulombs to the ground. And all of this occurs in about a millisecond. Now, we know from physics that when you have the acceleration of electrons in an antenna, you generate radio waves. So basically, every lightning discharge on the planet is a source of radio waves, which propagate out in all different directions, and also very broad frequencies, from all frequencies, from even waves of microwaves close to the lightning, all the way out to radio waves. Now, maybe I can go back to the full screen. Dr. Gua, just tell me if you don't see the slides. So
I can see the slide on Earth-Ionosphere waveguide.
Can you see the slide?
I can see that. Yeah, Earth-Ionosphere waveguide. Yeah, that's fine.
Okay, great. So now, luckily on the Earth, we have a layer up at about 60 to 100 kilometers called the ionosphere, which is highly conductive, and therefore this reflects some of the radio waves which are produced by the lightning back down to the surface. And in fact, the Earth's surface and the oceans have a very high conductivity, around about 1 Siemens per meter. The ionosphere is about 10 to the minus 5, but the air in between is a pretty good dielectric, about 10 to the minus 14 at the surface. And therefore, we have a waveguide produced by the ionosphere and the Earth, which can help propagate these electromagnetic waves around the Earth. Now, the propagation distance depends on the frequency of the waves, and it turns out that the higher frequencies will decay very rapidly. As we go down to the very low frequencies, what we call ELF, or extremely low frequency waves, these actually can be trapped and go all the way around the planet a number of times before they decay into the background noise. ELF, or extremely low frequencies, generally below a few hundred hertz. But in this talk, we're going to talk even about below 100 or even below 50 hertz. And so this Earth ionosphere waveguide between the Earth and the ionosphere results in a waveguide allowing for these waves to propagate around the planet. And when that happens, we can actually get constructive interference. If we think of a lightning flash here in the middle, we have waves will be going eastwards, others going westwards, and eventually at a certain frequency, depending on the actual size of our waveguide, which is determined by the radius of the Earth or the circumference of the Earth, we'll get the red standing waves, which will have various maximum in some places of the globe relative to a lightning discharge, and will have minimum or in other parts of the globe. And so this is exactly what happens when we look at the Earth. We have, from one single lightning flash, we can get these standing waves, electromagnetic standing waves around the planet. And a German scientist, Wolfgang Schumann, in 1952, he was the first one to actually predict that these standing waves, these resonant waves, should exist between the ionosphere and the Earth's surface. And he basically, we call these the Schumann resonances now, named after Schumann. And we can calculate the frequencies of these. It's fairly easy by looking at the speed of light divided by the circumference, 2 pi a. So
Colin, sorry, we are still at Earth ionosphere waveguide slide. So I believe that you are
okay.
Yeah, now it's okay. Yeah.
So I'll just leave it outside.
Yeah, thanks.
So Schumann was the first one to basically predict this, and so we call these the Schumann resonances. And the frequencies are basically determined by the circumference of the Earth, 2 pi a, so the radius of the Earth, the speed of light, and we have different modes of the harmonics. Schumann actually predicted that the first harmonic should be at 10 hertz, but he assumed that the ionosphere was a perfect reflector. In reality, it's closer to 8 hertz, the first harmonic, the second one closer to 14 hertz, 20 hertz, 26 hertz, and so on. So these are the standing waves, like the ringing of the planet, the electromagnetic waves, which are produced constantly by lightning around the planet. So I've been working in this field for close to 25 years, maybe longer. We have field instruments in the Negev desert. This is electric field, vertical electric field ball antenna, which measures basically the field between this ball and the surface of the Earth with some insulation here. We have a Teflon neck which isolates it from the ground. And we have 2 induction coils which are buried in the ground. One's in the east-west direction, one in the north-south direction. And so we can get the 3-dimensional picture of the electromagnetic field in the ELF range, which is coming into our station. Now, why do we have a station in the desert in Israel? This is because these fields are very, very small, very weak. We're talking about magnetic fields of picotesla, 10 to the minus 12 Tesla, which are way, way smaller than even the Earth's magnetic field. But these are the AC fields. They're varying in time, unlike the Earth's DC field. And there's so much electromagnetic noise today in the cities from all of our activities, whether it's the trains or the broadcasting radio stations, just the power lines, the 50 hertz, 60 hertz in the United States, that if you try to measure these harmonics, these Schumann resonances in the city or close to the city, you're swamped by the noise. And so it's very difficult to see them unless you go very far away from urban activity into remote regions like in the desert. So here we can see just 2 seconds of data collected from one of our sensors with filters at 100, 0 and 50 hertz. And we can see basically this, what looks like background noise for 2 seconds. This is for the magnetic east-west component. But when we take the spectrum of this, we can see that we get very nicely, not all the time. I'm showing you one of the best spectrums we've had. We see a peak at 8, 14, 20, 27 hertz, 33. And we also see the very large man-made 50 hertz power line signal, but it's very narrow, and we can filter this out so it doesn't interfere with the data. So these are the peaks of the Schumann resonance, which we actually observe. The amplitude of them changes constantly as a function of hour of day, day of the week, month of the year, depending on how much thunderstorm and lightning activity is occurring around the planet, as well as where it is relative to our station. But the actual frequencies remain the same. The frequencies are determined basically by the radius of the Earth, which doesn't change. And so the only thing that changes here is the relative amplitude of each peak that we see in the spectrum. And from that, we can also get some interesting information about where the lightning is coming from. So to show you that these are really global signals, these are standing waves which propagate around the planet, we can see two different data sources taken, one in Israel on the top and one in California, looking at the amplitude of the 8 hertz signal. The California data was taken off the internet. They have different instrumentation, different analysis, completely different, but we still see on the daily basis that these two plots are very nicely correlated, correlation coefficient of 0.9, implying that if you do have a good, clean measurement of the Schumann resonances, they represent global lightning activity around the planet. Okay, so if we look at this, the lightning, maybe I'd like to try to go full screen here because I'm hiding some images. The total lightning, I've just shown you the spectrum from the lightning 8, 14, 20, 27 hertz. On the right-hand side, we have additional spectrum. You can see the frequency is 0 to 70 hertz. But these are not from lightning. These are from the electric spectra in living beings, in living animals. We can see the sea lion, snake, the shark, octopus even. And we see peaks which occur similar in some of them, especially look at the shark, in the range of the lightning spectrum in the atmosphere. If we look at zooplankton in the ocean, this is a tiny little creatures in the ocean. We also see here a peak around about 8 hertz and another one between 14 and 17 hertz. And most important, when we look at the brain, the human EEG, here you can see the spectra with the frequency at the bottom at 4 different locations on our head. The y-axis is basically time, and I've added here 4 vertical lines for each of the places on the brain, which represent where we would expect to see the Schumann resonance, 8, 14, 20, 26. And we see that often the peaks we see in the EEG somewhat align with the Schumann resonance. It's not always, but when we do have peaks, often these are related to what we see also in the atmosphere. So the question is, have these weak lightning fields in the ELF range had any impact on the evolution of living organisms on Earth? Well, it's very difficult to answer this question, but this is our kind of working hypothesis that we think that this cannot be coincidence. And why not? We have other examples where we've seen this happen in nature. And this is
Colin,
when we look at
yeah, I see you are at slide 12. So can you cross check? Yeah, now it's okay. Slide 13. Thanks.
Okay. Did you see before the changing slides?
Yeah, we have seen that. Yeah, but we can now
Okay,
proceed to slide 13. Yeah.
Okay, I'm on slide. This is 13. So the question is, why do all animals and all humans and living beings see in the visible part of the spectrum? And scientists basically claim that this is because what nature gives us from the sun, this is the solar spectrum. The yellow curve is the solar spectrum outside of the atmosphere. The red one is at the surface where we have the absorption through the atmosphere, so there's a difference. And the black curve is a black body radiation theoretical spectrum for a body of 5,250 degrees. So when we look at actually our eyes, the sensitivity of our eyes, we see we have night vision and day vision. It's slightly different, the peak sensitivity where we can see, but it's in the green and the blue mainly, but we can see this is a log scale. This drops off dramatically as we go into the infrared part of the spectrum, which is shown here on the right of this dashed line, and the ultraviolet to the left. So we can only see in the visible part of the spectrum, but the question could arise, why don't we actually see also in the infrared or the ultraviolet, because that's what nature's also given us? Well, life forms started to generate in the oceans. And if we look at the absorption of radiation, function of wavelength or frequency here, into water, we see an interesting thing that for the UV, which is the photoelectric absorption, we can see very high absorption. So UV radiation doesn't penetrate very far into water. On the other side, we have the infrared radiation, which results in vibrational, rotational absorption. And just by the visible, maybe by chance, just in the visible, we see we have a lot of penetration into the water. And therefore, the radiation energy from the sun can penetrate into the water in the visible region, but in the infrared and the UV gets absorbed very quickly. And hence, evolution has basically used what could get into the oceans. And when we look at the penetration of light into the ocean, we can see that basically the blue light can go down up to about 200 meters, while the red is absorbed more, as well as the violet. But for life forms which need the solar energy for developing, for photosynthesis in the oceans and other life forms, only the visible radiation goes all the way down. And therefore, over evolutionary timescales, that's what there was in the oceans to use. And therefore, we have evolved to use basically the visible radiation from the sun and not the UV and the infrared. Now, some animals and insects like bees can actually see in the UV, and so it's not for all living beings. Maybe some things have evolved over time, but generally all animals, all living beings are most sensitive in the visible part of the spectrum. Now, it's interesting to look at this plot.
Colin,
yes,
you have around 2 minutes, maybe.
2 minutes, okay. So basically, this clock shows you the evolution, 4.5 billion years of Earth's existence. And I just want to point out that man has only, Homo sapiens have only been on the planet for about 4 seconds, last 4 seconds in a day. But lightning has been around, and the ionosphere has been around for billions of years. And therefore, it's very likely that the Schumann resonances have existed for billions of years. And if we look at this plot again, the ELF radiation goes even further into the oceans than the visible. And therefore, the ELF would have also affected life forms in the ocean. So just to show you some examples now of how Schumann resonance can affect biology, I don't have too much time, but I want to show that circadian rhythms, or the biological clock, that we sleep and we work overall 24 hours a day, and this remains constant when we see day and night, the light outside, the dark. But if you get put in a closed room, then, which is this back panel, but also when you do this with animals, birds, for example, their biological clock gets longer and longer. The days get longer and longer. And what we can see here is the activity of this bird over a 24-hour period, in the next 24-hour period. When we induce the field of, say, 10 hertz or 8 hertz around the cage of the bird, if we then we turn off the field, but the bird doesn't know if it's day or night. The light's on 24 hours. The days start to get longer for the bird. And then we turn it on again, the field, the Schumann resonance, and it stabilizes. Turn off the field, it gets longer once again. So this has been found to work with humans as well as animals. Some recent studies showing that treatment of spinal cord injuries can be done using the Schumann resonance or multiples of their fields, and therefore something about these frequencies is important for the healing of spinal cord injuries. And we've been looking at rat cells, cardiac cells from rats, where we take the cells and we grow them in a lab, and we put the 7.8 hertz field around it. And here too, we see significant impacts on the cells, sometimes positive, sometimes negative. And the last experiment we've been doing is looking at photosynthesis. Our plants may be impacted by these fields. And what we found is that plants can maybe change their productivity when we induce these fields around them. And they can also become maybe more tolerant to stress, like drought stress. And so there are many things we're finding now that can actually be influenced by these fields. Since I'm running out of time, I'll go straight to my summary and conclusions. So lightning activity has been active in our atmosphere for billions of years, and due to the Earth ionosphere waveguide produced by the conducting surface of the Earth and our ionosphere, these waves, electromagnetic waves from lightning, especially in the ELF range, the extremely low frequency, they propagate around the globe, producing standing waves, what we call Schumann resonances. And the spectral patterns of these Schumann resonances are very similar to the electrical activity in many living organisms. And various experiments done by us and other groups show that these living organisms, today we can induce changes in them as well as plants by changing and inducing these frequencies. And one important find is it's the frequency we think which is important and not the amplitude of these fields. And so we hypothesize that the global ELF fields from lightning have impacted the evolution of life forms on Earth over time. And we continue this research to try to get more and more evidence to link these two phenomena together. So thank you very much. I think I'm done. Just to tell you that if people are interested in more information, we published last year this paper in the International Journal of Biometeorology on natural ELF fields in the atmosphere in living organisms. And for more information about our studies and more references, you can go to this paper and get some more information. Thank you very much.
Yeah, thank you, Professor Colling, for this highly interdisciplinary and interesting presentation. So we have time for a quick question. But if we look at the chat window, we have a question from Ritanava Bonik. He's asking, can you see the question, Professor Price, in the chat box?
No. Yeah.
Okay, so I can read it out. Okay.
Yeah, it's in your field work. Do the measurements affect by the natural calamities like sandstorms and ice avalanches? How do you optimize the measurements? So yes, definitely local storms and local influence can influence our measurements. Dust storms we haven't seen, but solar storms, for example, when there's a solar storm, coronal mass ejection or a solar flare, which propagates down and also influences the ionosphere, we can see changes in our measurements at the ground. Some people have claimed that you can see changes in the Schumann resonance parameters related to earthquakes. I think this is still debatable, but it's possible that maybe from earthquakes, this affects the waveguide and we can then detect changes in the Schumann resonances. Obviously, lightning close by thunderstorms will have an impact, and that doesn't then supply us global data. But definitely, there have been people trying to look to see whether we can use our measurements, the field measurements, to look at other natural disasters, especially earthquakes, but also space weather and solar storms. I hope that answered the question.
Okay, yeah. So I think there are other questions, but due to limitation of time, what I will do actually, I copy the questions and send it to Professor Price. And I would also request the participants to just email Professor Price. If you search Google by Professor Colin Price, Tel Aviv University, we'll get his email address, and you can, of course, write to him. And with that, I think Professor Price, hello. I think we are out of time because the second speaker is waiting. But very quickly, Colin, if you can address, I can allow. Just very quickly.
Okay. Well, first of all, I put my email on the chat, so if anyone wants to contact me. First of all, the giant planets don't have a solid surface, and so it's difficult to say if they have a waveguide to produce the Schumann resonances. Some people have suggested using Schumann resonance to detect lightning on other planets, but for detecting the water vapor, I have to think about that. I'm not sure. Don't have enough time now, maybe offline.
But thank you very much. Means we started on time, and I believe that the talk was so interesting that people will definitely get in touch with you, Professor Price. And thank you very much for accepting our invitation, and we will be hoping to see you again in such a conference. Thank you, sir. Thank you.
Bye-bye.
Bye. With that, we come to the end of the first invited lecture of this session. And now I believe Professor Ramesh Chandra Tiwari is present. Am I audible, sir? Can you unmute your microphone?
Yeah, yes, sir. Yes, sir. Yeah.
Okay, okay, thank you. So before you start your talk, sir, I just to introduce you to the participants. So Professor Ramesh Chandra Tiwari works as a senior professor and head of the Department of Physics, Mizoram University. He has been teaching, he has teaching and research experience of about 31 years and 28 years respectively, administrative experience of 16 years as dean and head. He underwent a LEAP training also, and his current research interests are radiation physics, electronics. Under him, 6 PhDs are awarded till now and 8 scholars are registered. He has visited 7 countries, including Vienna, Austria, IAEA invited experts, and he has filed 3 patents and 1 policy document, 6 research projects, 84 publications, 85 invited talks. And he's also a member of UGC inspection team, EC of NELIT and MZU, NAC convener, MZU and AC, and many other committees. And he's also a NAC assessor, which is very important for assessment process of universities. Has a vast experience, so we'd like to hear him from now. And the topic of his lecture is study of mechanical, optical, and electrical attributes of X-ray machine to understand radiation hazard. Professor Tiwari, the floor is yours. You can share your screen and start your lecture. Thanks.
Thank you. Thank you very much, Dr. Anirban, for your nice introduction and highlighting about the talk also. Is it visible? The slide?
Let me wait for some time. It's not visible till now, but we are waiting.
So, like entire screen, there are 3 options. So, which one works better? I was sharing.
You should share the whole screen.
That is better.
Yeah, that is better. And then share. Click share.
So, like before clicking the sharing, do I need to open in the window first, or?
Yeah, you open the file first, then you share entire screen.
So
yeah, please open the file first, then you share entire screen. Yeah.
Okay. Is it there? No.
Not yet. Now, have you shared it now? It's
yeah.
Yeah, sharing things coming. Yeah. Yes.
Thank you, Dr. Kolita, for assisting Professor Tiwari.
Yeah, thank you so much. So is it visible? The screen is still.
It is now visible. You can now go to the presentation and just your presentation is at the bottom of the taskbar. I think it is visible. Your screen is visible.
Okay.
Yeah.
Thank you.
You can go to full screen, sir, so that participants can see it clearly.
Okay, now?
Thank you, sir. Thank you.
Thank you so much. So this particular presentation which I'm going to make is about the study of mechanical, optical, and electrical attributes of X-ray machines to understand the radiation hazard. So as we all of us know that the X-ray machines are a kind of integral part of our life. For any kind of trouble we have, where we want to see any kind of fracture or any other related things, whether it is a problem in the teeth or so many other things. So the X-rays are one of the most popular device that we use. At the same time, they are the source of radiation, which can be harmful if there is a problem in handling. So that was the objective for this work which we did. And here, actually, our scholars worked for 6 years, from 2014 to 2020, and then we have been able to produce a policy document out of this work. And this policy document, as you can see in my screen, it is available at the International Atomic Energy Agency Vienna website. So anyone interested can see there. It is their website, INIS. So under that, in this particular address, you can go for this. And so in this study, what we have done is, as you can see by the title, we have tried to diagnose the X-ray diagnosis machines. That is the in short, I can say. And we have tried to check their mechanical properties, whether they are fitting their location wise, all the components are in place, whether there is a leakage of the radiation or not. That means optical properties, many other things also. They're focusing it proper, or the instrument is leaking the radiation. And then at the same time, we have also focused about the electrical properties, where we have checked whether the instrument, the machine is getting a proper voltage, whether it is getting stable voltage, and so on. So that is why these three things have been put here: mechanical, optical, and electrical attributes. So this has been the outline of our work. And this is what I was telling you: 50 years of INIS, International Nuclear Information System, where our document, you can search. If you write full name, my name, and or any other's name, authors, then you can get it. So a brief introduction, because the time is very limited, so I will not be going into very much detail. So here, on the one side, one aspect of the X-ray machines is that they are integral part. We have to depend on them for so many diagnosis things. So no doubt about that. At the same time, we need to be careful while using them. Why careful? Because those people who are handling the machines, those people who are the patient, and those people who are the relatives of the patient, and also general public. That means the surroundings, people who are visiting these X-ray installations, they all are prone to those problems. They are prone to radiation hazard if we don't care properly about the X-ray machine. X-ray machine, when we say care, that means we need to do what I told you in the first slide. Those things we need to check regularly. And if you see in this slide, about 51% of the population dose was estimated to be caused by diagnostic X-ray examinations. So when I write this, I mean to say that although the X-ray machines are integral part, we need them badly for whatever purpose. All of you know, I'm not going to explain that. But what is written here, this data is about 51% of the population dose, which that means people get dose, 51% of that is coming from diagnostic X-ray machines. So this doesn't imply or indicate that we should stop using the X-ray machines. No, it means that we need to be careful about the regular checkup and regular training of those people who are handling it. These things are required so that this particular percentage can be as less as possible. Here you can see the map, and these green, red, all those things are there, which indicate the hospital, community health center, primary health center. So we tried to visit each and every X-ray machine in the entire state of Mizoram, wherever it was, whether it is in the remote place or whether in the main city. We did not bother. Our scholars did very hard work, and they personally visited everywhere and tried to take all the data about the machines. So you can see that our location is between Myanmar and Bangladesh. For those people who are not from North-East, sometimes they are not very clear. So here in between, this particular state is called Mizoram, and here we have around 11 lakh population, and out of that, so many hospitals, so many community health centers, so many primary health centers are there. So we thought that why not go and diagnose all these machines to come up with a with some suggestions if required. If we find certain problems, difficulties, or requirements to improve the functioning of these machines, then with that objective, we started the work. So we covered 100% full machines at that time in the entire state. Then here, if you look at the entire number, the total number is 169 machines in the different districts. You can see, I'm not going to read them because the time is limited, that's why. And out of that, you will find that out of 169 machines, 105 are available at the Aizawl, that means capital of Mizoram, because the large chunk of population is there in the capital. That's why. So 62.1% of the entire X-ray machines are located in Aizawl. Then when our student study, he also study about the condemned machines events. So 26 machines were condemned. Those also he took in our study. Then if you see the next table, it gives about the workload. So if you look at the data, there are different type of machines. For them, the workload has been given. So for 195 machines, 135 machines, that means 69.2% of workload is with the conventional X-rays, because you will know that there are different type of X-ray machines, not just one type. The conventional type, dental type, and so on. So we have tried to CT scan and so on. We have tried to include all. And if you look at the second table, 5172.16, that means 90.9% of the total workload comes to the share of conventional X-rays, and about 140.06, that means 2.5%, dental X-rays, and others 6.6%. So that is the situation. That means the workload which are to be performed are given to the machines. That means people visiting to those machines. And as I said in the beginning, there are different properties. Mechanical, under that optical and radiation field congruence, central radiation beam alignment. I think these properties are very important to check the optical situation, whether the proper X-ray beam is generated, whether it is reaching to the destination, and so on. The second, input-output characteristics of the conventional X-ray machines, as I told you in the beginning, electrical properties here. We have tried to see accelerating potential, tube current, and so on. Then the third part of the objective which we took up was the radiation characteristics of X-ray installations. There also we tried to see whether there are scattered radiations, whether there are radiations outside the machine, and whether there are radiations when the machine is kept off in that time also, leakage. So all these aspects we taken into account while making this particular study. Then here the instruments that we used, red check plus, that is for output radiation of diagnostic X-ray machine. Then we also use KVP meter, which measure the effective peak potential. Then we use survey meter, which measures X-ray as well as gamma radiation above 25 keV and beta radiation above 1 MeV. So this can be used for that purpose. This also we use in our studies. Then we make some simple tool to understand the beam alignment, which you can see here. Then when anyone working around with the machines which produce radiation, which can be hazard, then you require to have a badge, TLD badge we call it. So thermoluminescent dosimeter badge. So this badge was used by my student. Name is written here also, Lalin Moya, Jonathan Lalin Moya. So he used this. So this particular badge absorbs the radiation to which you come across. So after a limited period of time, we can send this badge to the laboratory, which is situated in Chhattisgarh, and BRC accredited laboratory, where they can give you the dose, amount of the dose which is absorbed by the person. And therefore, a suitable advice may be given to that person, whether he or she has absorbed more than the limited dose, or less, or still he can work like that, like that. Then it's the same thing which I told in the beginning, that we use the different tool and try to understand whether the leakage is there or not. Then mechanical property, as I told you, radiation beam, optical field congruency. Here we studied the phenomena, and here the maximum allowed misalignment, incongruency between the radiation beam and so on is also studied. And this we followed the BRC and Atomic Energy Regulatory Board protocols, I can say. So here the optical field 2%. The last line, if you see, the maximum allowed misalignment incongruency between the radiation beam and the optical field is 2%. So if it is a variation of 2%, it is very well acceptable. Then if you talk about the angle between central beam of X-ray and the plane of the image receptor, this should not differ by more than 1.5 degree. This all is given by the standard protocols from Atomic Energy Regulatory Board, Mumbai, because this work was done under their project also, they funded it. Then here attenuation, we use the aluminum sheet. Then first we do the measurement without sheet, then we go by different thickness sheets, as you can see here, 0.51, 1.52, 2.53 millimeter of aluminum placed in the X-ray beam on top of the test stand. So that is how we perform the measurements. Then according to AERB safety code for 70 to 100 kV, the minimum filtration of a useful beam for a maximum rated operating tube potential should be 2 millimeter of aluminum. So this is the in general. However, according to the international standard, it can be 2.5. Of course, we have used to taking AERB safety code, Atomic Energy Regulatory Board. So we have followed the national standard in this study. And these are the other properties which come under the electrical properties: output linearity of current, time, reproducibility. Here the third point is very important, that if you apply a fixed input and you measure the output of the X-ray beam, and if your output in so many, suppose you take 5 readings with the same input voltage, and the output gives exactly same value of the X-ray, that means there is reproducibility of the output. So this is very important, one of the most important parameters in this kind of a study, that a particular given voltage output should be exactly what is expected, because it is to be applied to the patient, and therefore the variation can be dangerous for the patient, because a particular wavelength or particular type of X-ray has been recommended by the doctor. So this particular point, number 3, is very important. Then output linearity of time. Under this also, different time intervals the experiments were performed, 0.2, 0.4, 0.6 and 0.8 seconds. And here the coefficient of linearity was calculated by using appropriate equation. This is standard, again, AERB. So it should be between 0.1 to 0.1 or 10%, less than 0.1 or 10%. So up to here, the data is acceptable, no problem with that. So up to variation of that. The same is the case with the current. Here also, the variation up to 10% is acceptable. Then output reproducibility, as I was telling you, the coefficient of variation CV obtained using appropriate equation was accepted at 0.05. That means 5%. It can be 5% or 0.05. Okay. Then the tube output at 70 kVp and a typical tube loading, the X-ray dose was measured at 1 meter, the 100 centimeter focus detector FDD distance. Then why this is very important parameter? Because here we evaluate the patient's skin dose, because the dose which is given to the patient, whether it is going in the proper area, if it is going beyond the area, then how much the dose has been absorbed by the patient. That is a very important parameter. So that is shown here. Similarly, the
Professor Tiwari.
Yes, sir.
Professor Tiwari. Yeah, you have around 1.5 minutes to complete your talk.
Okay, sir. Thank you, sir. Thank you, sir. I'll finish.
Okay, thanks.
Thanks. So here, since the time is limited, so I'm not going to talk much. But here in this particular slide, you can see that we took 16 important safety parameters in our study. So if any one of you are interested to replicate our work, you can always do that. So these parameters are very important, and these things are given in that free download documents, as I told you in the beginning. So no issue, you can download and work on this. Now I will go straight to the recommendations that we did. This is the comparison of our data. So here we came out with the implementation strategy recommended by our group, where we requested the government of Mizoram to do regular quality control, to have strict quality control measures for all the machines in entire Mizoram, and be careful about the protection facilities which are provided there. Then the participation of medical physicists, that means we also recommended that the people who are expert in the area should be involved in the different type of activities, so that people are aware about the radiation hazard part of the X-ray. Then other things are also there which we recommended. The radiation workers, they should get up-to-date training, because whenever the new machine comes, they should be trained in a proper way, so that they are up to the mark and do justice with the patients. So all these things we publish in different publications in Scopus. And as I told you in the beginning, that the policy document which we generated, it was submitted to the International Atomic Energy Agency, Vienna, and after the approval of the Department of Atomic Energy, Government of India, Mumbai, it was accepted and it was published. So this can be accessed by any one of you, and I'm very thankful that to listen me, although I'm going very fast. But one thing is there, that if you are interested in this area, it can be a good work, and any researcher interested in this can replicate, and our documents are available for free download. So if you have any other queries, you are very much free, and I'll be very happy to respond. Thank you so much.
Thank you, Professor Tiwari. Your lecture was full of information. Maybe we are providing more time for the contributory people to present their things, but invited talks always inspires us, so that we can get in touch with experts in future. If anyone have interest, definitely they will get in touch with you. Before we go to the contributory session, I see one question from Jyoti Ringna.
Yeah,
which instrument did you use to calculate the attenuation? That was one question I see in the chat box.
Oh, I think, can I go back to show that?
Very quickly, if you go.
Aluminium sheet is there, and yeah, it is here. Here you can see, please. That one who has made the question, you can just take a snap here, a picture here. So actually, here what we did, the tube voltage we keep fixed, and the tube loading at a constant exposure was made without the aluminum. First we did without aluminum filter, then we put aluminum sheets of 0.51, 1.52, 2.5, and 3 millimeter. So in different steps we did this. Okay, and then we calculated the transmission percentage.
Yeah, okay. So another question we have, Shankarampadi asking, safety-wise, how much is the difference between the machines for X-ray imaging and machines for in vivo radiation therapy for cancerous cells?
It's a very important question, but the thing is that anywhere, wherever the X-ray radiation is coming out, which is not required, is a radiation hazard. So I cannot say that this particular is good, this particular is bad. The solution to this problem is that the machines should be in a good condition. If they are not doing any radiation leakage, if they are handled properly, if the person handling is aware about, then I think that is the solution. And all are for our good, for our own help in different works. So
yeah, okay. Thank you, sir. So I think there are more questions in the chat box, which shows that the presentation was excellent. But due to limitation of time, we cannot discuss it here. But I would request the participants, if you have any questions, just drop an email to Professor Tiwari, and we'll be more than happy to answer, I believe. So,
sure.
thank you, sir. So definitely it was a nice presentation, and thanks for accepting our invitation to
So much because
present your
our
work.
organizing committee, Professor Bhattacharya sir, Professor Arshad Hussain, and everyone, I would like to thank and giving me this opportunity. I'll be very happy to talk again whenever there is any chance. Thank you so much.
Thank you, sir. See you again, sir. Bye, sir. Thanks. So with that, we come to the end of the invited lecture session in this session. Now, there are 7 contributory papers. Those are oral presentations, some in core atmospheric science, some in interdisciplinary field. Just for the participants or the contributors, I would like to say that allotted time is 10 minutes. But it is better that you target 8 minutes so that you have some time for discussion for 2 minutes. So maybe before 8 minutes, I will give just a mark that your 8 minutes is coming, and then you have to wrap up, because it is also a competition. So you have to understand it that in a competition, everyone has to have the similar opportunity. With that, I would like to now ask Parminder Kaur from Tripura University to present her talk on semi-EDX-based morphological and chemical characterization of aerosols generated during wood burning. Parminder, the floor is yours.
A very good afternoon. Am I audible? Please, someone confirm.
You are audible. Please go ahead.
A very good afternoon. I am Parminder Kaur, a research scholar working under the supervision of Dr. Anirban Guha at Department of Physics, Tripura University. Today, I am going to present on semi-EDX-based morphological and elemental characterization of aerosols generated during wood burning. So, in a brief introduction, while it is understood that both open and controlled biomass combustion are major sources of aerosol particle in the atmosphere, many questions remain regarding the properties of these emitted aerosol particles, their shapes, their sizes, their relationship with the combustion condition and the fuel type are still unanswered. So in this regard, it is very important to study the properties of these biomass burning emitted aerosols during our reason-based studies. So also, the emitted primary particles mainly composed of organic aerosols, black carbon, aerosol, brown carbon in varying amount, and many other elements, some trace metals and inorganic species. So my today work is mainly revolves around the kitchen emissions. So it's shown in here my slide. It's mainly revolves around the kitchen emission in the rural areas. Next slide. Here's the outline of the work, that is from objective motivation and some discussion about the experiment, then results and references. Next. Objective. The objective of my work is to mainly get the morphology and the particle emitted during biomass burning along with the elemental characterization. So this study of the evaluation morphology and elemental composition of combustion emitted particle in different burning phases, that is mainly smoldering phase and flaming phase. These are two main burning phases. So we are studying the particle emitted from these during these two burning phases. And the other objective is to observe the change in morphological and elemental behavior in the generated particles in the mentioned all these groups. So with these objectives, we will mainly able to understand the kitchen wood pools on the rural environment and health of the rural people, how these wood burning aerosols affect the health of the rural people and the climate. Next slide. So here are the main phases of burning. Number one, image shows the flaming phase. Number two is the smoldering phase, and number three is there are both phases are at a time. These are flaming and smoldering phases. Next, please. So why to conduct this study? Why this study is important? As we know, rural people typically burn woods in chullas about 6 to 7 hours daily. So mainly for cooking their meals and other household activities. So the particles and smoke generated from this wood burning, different woods, mainly affect the health of family members. So with this, the women who work in the kitchen and for the rural kitchens. So to study the effect of those different woods on the health of the family members and people, it is very important to conduct these kind of region-based studies. So, and also our results are very much useful for the researchers who study regional and local climate models, as they always require region-specific properties for those models. Next. Study location, we have conducted the experiment physics Tripura University, and it's in North-Eastern India. So here in this figure, I have shown this schematic diagram of our experimental setup. We have a chula, there we have burned some different woods we have collected during our survey, and we have an instrument named accelerometer that we have used to collect the particles, emitted particles on the filtered quartz fiber crystals, and also this instrument will give the black carbon concentration for any wood fluid. So once we have taken the quartz fiber filter from the instrument, then we have extracted the central part of the fiber filter, and we further have used that for the SEM EDX characterization. Next slide. So coming to the result part. Here I have shown some of the morphological clusters generated during the smoldering phases for different woods. So in this samples, what we have seen in the smoldering phase, we have some clusters. The first one is mainly the iron-rich cluster, then the calcium-rich and other cluster. What we have observed in the elements, main elements present here during the smoldering phase are sulfur, then calcium, then iron, magnesium, then some very small amount of aluminium and potassium. For all 1 to 4 results. Next slide. In the flaming samples, again, we have observed this presence of similar sample, but that elemental weight percentage is different. How for like in case of smoldering, what we have observed, the iron was higher for those samples, but here the aluminium was higher in some samples. But at the same time, we have observed the presence of similar elements. This is sulfur, then calcium, then we have also observed the presence of some nickel and copper things here, and the elements we have observed are the same, more or less same. Next. So in this figure, the above panel, all these three figures are for a smoldering phase. These clusters are known as soot clusters. What is soot clusters? Soot clusters are actually made from very tiny elemental carbon particles. It's only up to few nanometers. When they combine each other, they made a soot. So we have observed the presence of soot in both the flaming phases, burning phases, in flaming and smoldering. But during the smoldering phase, we have observed the larger in size and also in the composition larger soot cluster than the flaming phase. Next. I have shown some of the results for only 3, not for all the samples. But we have seen the very important thing, what we are looking for is the elemental carbon. And we have observed that during the smoldering phase, in all the times, we have observed the carbon more in the smoldering samples than the flaming phase. Elemental carbon is very important, one of the very important components here which we are looking for. But there is only 1 or 2 samples where we have observed the different opposite behavior of carbon, where we have observed the carbon is higher in that case of flaming than the smoldering. That is only for 1 or 2 woods, and rather than that, in all the samples we have observed mainly carbon is dominating in the smoldering samples. Next. So, coming to the discussion part, what is more important to understand? Here, it is very more important.
Parminder.
How this particulate matter, this black
Parminder,
segment enters.
can you hear me?
Actually, these particles mainly enters into our body through our mouth and nose when we breathe.
Parminder, can you hear me?
Some of the larger particles, those have more than 2.5 micrometer in size.
Parminder, your 8 minutes is over. If you can hear me.
Yes, sir.
Your 8 minutes is over, so you have to wrap up within 1 minute.
Actually enter into body and they cause many health issues like skin irritation, eye irritation, some lung problems, respiratory issues, and mainly they also cause cancer. So in this regard, it is very, very important to study these elements and to know their effect on our health, especially on the women's health in the kitchen who works. Next slide. So with this, I have listed out in the last slide some of the major elements what we have observed during our samples. So here I conclude, because to better understand the role of these particles and study some more studies are important on the regional basis. Those regarding harmful elements present in the air and the morphologies. And moreover, aerosol particle composition and morphology highly depend on the type of fossil fuel, the burning condition, and the phases and the fuel type. So in this regard, more and more studies are required on the regional basis. Next. Acknowledgement. I would like to thank you, thank Indian Space Research Organization to support provided under the RP project and the Department of Physics, Tripura University. I also would like to thank the organizers of Biennial 2021 conference for providing the opportunity to present the work here. Next. Here are some references, and thank you very much.
Okay, thank you, Parminder. We have time for a very quick question. If anyone has a quick question, they can ask. I don't have any question here, so Parminder, thank you very much for your presentation. We now move forward to our next presenter, Orchuna Bora from Guwahati University. Are you present? Orchuna Bora from Guwahati University.
Yes, sir. Yes, sir.
Okay. So your time will be 8 minutes plus 2 minutes for discussion. Your title of topic is Application of Artificial Neural Network to Determine the Thickness Profile of Thin Film Sample. Time starts now.
Very afternoon, respected chairperson and all the participants present online and offline in this conference. My topic is application of artificial neural network to determine the thickness of profile of thin film samples. And the main objective of this work is actually to explore the use of artificial neural network to find the thickness of thin films while the film is growing on the substrate. And we have used the phenomenon of interference of light for this. In my talk, I will, in the beginning, give a very thin, very brief introduction to the thin film, and then I will be touching upon some of the important points on the ANN, and finally, I will move on to my work. So basically, what is thin film? A thin film is a layer of material ranging from fraction of a nanometer to several micrometers in thickness, and in these films, their surface property dominates over the bulk properties of the matter, because of which they have found many applications in industries. And as the thickness actually defines the properties of these layers, therefore, the thickness measurement is a very important factor while looking for some applications of this thin film. There are many techniques for measuring this thickness. For example, these are some of the examples: ion beam analysis, TEM, ellipsometry, profilometry, etc. And in our work, what we have done, we have introduced or we have explored the applicability of artificial neural network, which briefly we can call as ANN, for this purpose while the film is growing. So why we are using artificial neural network? because current trends is we can see in R&D sector that or in the industrial application side that there is a tendency of automatizing everything with minimal human intervention, and this can be done with the application of actually this ANN. So our present work is actually a humble effort towards this approach, and without contradicting any of the so far well-established method of measurement of this thin film. Okay, so this is the purpose why we are using this artificial neural network. And very briefly, what is artificial neural network? These artificial neural network are actually a mathematical tool. They are composed of some very elementary units. We call those elementary units as the processing elements. And these processing elements are actually arranged in layers. There are lots of processing elements. They are arranged in layers. These layers are interconnected to each other. And these layers are together known as the network, this artificial neural network. Such network, at the beginning, what we can do, we can expose to a known environment. Known environment means where there will be given, this slide shows the comparison between the basic processing elements, this one, and the biological neuron. So what does this neurons actually, network actually do? So they are initially exposed to a known environment. Known environment means where they will be given some stimulus and they will be guided through how to respond to the stimulus, and they will remember this stimuli and the response. So later on, when a new situation will come, where they will encounter some new, unknown, previously unseen stimuli, but the stimuli will be of the same pattern as the initial, where they get exposed to, they will respond to that. So this session, this learning, this gaining of this experience happens through a parameter known as the activation function. And in our work, what we have done, we have used an architecture where this learning activation function is a sigmoid function, and this which can be represented by this mathematical expression. Okay, now the number of layers, the number of nodes means the processing units that we have introduced in the network, that can be actually very concise form. In a very concise form can be represented like this number 1001 to 64 that I have done. Here actually this 1001 represents the number of input, number of nodes at the input layer. 2 represent how many hidden layers, how many in between layer are there, and 64 represents the how many number of nodes are there in its hidden layers. And this known environment, unknown environment that I just talked about, those are actually known means the training session, and the unknown means the testing session. So to train a neural network, we will need the training data, and to validate it, whether it has learned that stimulus and the response correctly or not, we will need some validation or the testing session. Okay, so for that, what we have done, we have used the phenomenon, interference phenomenon. And actually, we have not done this part in the laboratory, but we have simulated. So what we have done in this simulation, we have considered a spherical wavefront represented by E0 and a planar wavefront represented by ER, and their mathematical expressions are given by expression number 1 and 2. And since we are considering the interference pattern, therefore for the clear feasibility, we are keeping the amplitude constant. And since they are coherent also, this time dependency of the first part is not going to affect anyway. They will be behaving like a constant term. So in later slides, we will not be considering the time dependency part of this case. Okay, now here I have given the typical experiment setup for the generation of this training and test data. Here you can see from the reference beam, that ER beam are coming from the left side. Suppose let us consider this direction from left to right, consider as the Z-axis, and detector is kept in the XY plane. And another converging beam comes, and incident on the thin film goes back to the detector and form the interference pattern. Those interference pattern will be concentric rings whose fringe which will decrease as you move away from the center of the fringe pattern. So here I have given the line profile of this interference pattern. In the lower panel, you can see this lower panel. There is an interference pattern, nice. And then in the upper panel also we have another interference pattern, which I will explain after a few minutes. And in this thin film, since we are considering the measurement of the thin films when the film is growing, so what will happen? The thickness of the film will not remain constant, but it will change with time. As the thickness of this film changes, what will happen? The radius of curvature of this spherical wavefront that is reaching on the detector system will change. Accordingly, the interference pattern will also change. So therefore, what we can do, we can map the interference pattern with thickness, and we can store them, and we can give that as an exposure, first exposure to the neural network. So basically that set of data will be considered as a training set for the neural network. After that, to give an exposure.
Dr. Bora,
yes, sir.
Sorry to interrupt you. You have around 1.5 minutes, so you can slowly start wrapping up your presentation.
Yes. Yes, sir, thank you. So for the testing type, what we will do, we will introduce. So we have introduced some noise from the detector, and similarly we will get this pattern as shown in the upper panel. Now to simulate this simulation pattern, what we have done, we have worked out this analytical formula where equation number 3 show the resultant wavefront, and since the phase of the planar wave will remain the constant, so delta phi is the spherical wavefront phase of the spherical wavefront, and which can be represented by expression 4. But you can see the thickness that is growing, and that is bringing the changes are not this original radius of curvature of the wavefront by 2t, and this t is in the nanometer scale, where this r0 is in the centimeter scale. So t is being very small. We can actually approximate this expression 4 by expression number 5, where the first term and the square root term is constant with respect to thickness. Only the second term is changing, and you can change x or y, whatever we can either keep x or y, we can consider other keeping 0 to get the line profile. So based on this equation, we have generated trained data set from thickness 0 to 40 nanometer, which is step size of 2 nanometer, and test set at the same range, which is step size of 1 nanometer. Wavelength, we have considered 500 nanometer, R0 to be 5, and we have considered the detector system to be 8-bit and 10-bit. And then we have trained the network. In the right-hand side, you can see this has got trained very nicely. On the left-hand side, you can see the testing pattern. That pattern you can see, it has detected the thickness.
Dr. Bora, you can conclude your presentation.
Yes, sir. Yes, sir. So similarly, for this 10-bit, this is just sigma is the noise level introduced, and based on this, we can see that the ANN can be very conveniently be used for the online thin film deposition measurement. Thank you, sir. These are the references, some of the references.
Yeah, thank you, Dr. Bora. It was a very nice presentation. So if anyone has a very quick question, they can ask. So one question is how you generated the data set and how you split those data sets very quickly, ma'am, if you can answer that.
As I shown here, the data set we have generated, we consider the thickness density from 0 to 40 at a step size of 20. And then we have also generated another data set with the same range of expand 0 to 40, but there we give the step size is 1 nanometer, and there we have give the Poissonian noise, as you can see, of sigma value 0.0626 for the 8-bit detector and 0.0312 for the 10-bit detector. As you can see here, the training set does not have any noise, but the testing set has a noise. So basically,
I think that you have given the answer. So the basic answer was how you have splitted those data sets. And I think you have satisfied the Manthan Ghosh was the participants who asked the question. So thank you very much, ma'am, for
Thank you very much for your kind attention.
yeah. So there are other questions in the chat box that you people can be in touch with the presenters because we have a limited time for this oral presentation. Thank you, ma'am.
Yes, sir, I am sharing my email ID in the chat box.
Yeah,
please.
you can
Thank
share and participants can get in touch with you.
Sure, sir.
I
Thank
would
you.
now request all the participants, while the session is going on, you can keep on typing your questions and I will decide which questions to ask. Instead of at the end of the lecture, I ask participants to ask questions. So those who are interested in asking questions, they can straightforward write in the chat box so that we can discuss it immediately after the presentation. So now we move on to the next lecture from Dr. Jhuma Bishwas from Pandu College. Title of the topic is Effect of COVID-19 Pandemic Lockdown, a satellite database appraisal of air quality in Guwahati, Assam. So Dr. Bishwas, are you present?
Yes, sir. Yes, sir.
Yeah, please share your screen.
Yes, sir.
Yeah, we can see your screen. So please start. Your time starts now.
Thank you, sir. A very good afternoon to all of you. I'm Dr. Jhuma Bishwas from Pandu College. I'm thankful to Panel Organizer for selecting my paper for this presentation. Today I will discuss on effect of COVID-19 pandemic lockdown.
Dr. Bishwas, sorry to interrupt you. You have to be a bit closer to the microphone because your voice is coming a bit low. So please come a bit closer to the microphone.
Okay, sir.
Thank you.
Okay. One of the most important problem in global environment is the climate change, where air pollution play a very major role. They can affect the global temperature along with the regional rainfall and hence reduces crop production. I have analyzed both the aerosol as well as refresh gas concentration over Guwahati by using satellite data. Now, first of all, what is aerosol optical depth? Well, aerosol is the measure of extinction due to atmospheric aerosol, which during its changes from surface of the top of the atmosphere to Earth surface. And I have used the term PM, which means particulate matter, which is the mass of aerosol suspended in unit volume of air in the atmosphere. And I have used the term PM 2.5, which means that particulate matter whose size is less than 2.5 micrometer. Now coming to the sources of aerosol, these are some natural sources of aerosol. This is volcanic eruption, sea salt, soil dust, biomass burning, etc. And anthropogenic as well as man-made aerosols includes industrial emission, vehicular emission, and indoor cooking, etc. So here I have shown the sources of SO2 and NO2, and it is clearly seen that burning fossil fuel are both common source of both SO2 and NO2. And this study is directly related with the COVID-19 pandemic, which affects every part of our human life. And in India, phase 1 and 2 lockdown period was occurred in the month of March 2020 to May 2020. And this lockdown affects the local environment due to the sudden shutdown of industry, factories, school offices, along with the reducing very vehicular activity. Now, this is the study location. Guwahati is the I have taken Guwahati is study area, and which is located in North-East India. And this North-East India, why it is important to study aerosol over this location, because it possesses a very unique topography with mountains all around, and only it opens through this waste where IGP location exists, and there is a possibility of transportation of aerosol from this IGP region to this study location, and there is a huge probability of increasing aerosol loading over the study location. Now coming to the objective part, my main objective of this study is to study the temporal variation of pollutants over Guwahati for the period of 2017 to 2021, and also the impact of COVID-19 pandemic lockdown on local air quality. This is the satellite data set that I have taken for this study. So this data are used for determination of AOD and site count map, and OMI data are used for OMI is ozone monitoring instrument data. Is used for measure the SO2 and NO2 concentration. MERA2 data are used for measurement of PM 2.5, BCM is black carbon, and rainfall over the study location. And coming to the result part, this shows the meteorology over the location. So I have studied the data from January 2017 to May 2021, and it shows a decreasing trend of rainfall over the location, with maximum rainfall are mainly occur during the monsoon season. This two figure shows this monthly as well as seasonal variation of AOD over Guwahati. So in the first figure, it is clearly rated. See that AOD is maximum in the pre-monsoon season, which is mainly due to the intense biomass burning activity, as well as there is a possibility of long-range transportation of aerosol from IGP section to this location in pre-monsoon season. And lowering of AOD in rotating monsoon. Rotating monsoon is October, November month. It is mainly due to washout of aerosol during the preceding month, and there is a very low probability of replacement of again aerosol. So it's very low in rotating monsoon season. So this two figures shows the monthly variation of both PM 2.5 and black mass BC mass concentration. The annual variation, it shows the highest in the pre-monsoon season, and it is lowest in post-monsoon season, as like aerosol optical wave. This figure shows the black carbon mass concentration. We do not show similar variability as the PM or AOD, because BC mass concentration is mainly associated with the local burning activity, which enhances during the winter months from December to February. Therefore, it is BC mass concentration is higher in the winter months, and it is lowest in this monsoon season, June, July, August, September, due to washout of this type of aerosols by rainfall. Now coming to the main of this part of this work, that is, so I have seen that there is a very reduction in the aerosol level during the pandemic year, which is 2020, because total lockdown was imposed in all over the India. So it is clearly seen from this figure that this is the black one means March, green indicates every month, and May indicates by this blue color column. So I have started data from 2017 to 2001, and I have here shown only the pre-monsoon months, so that we can compare the concentration level during the pandemic year to with the another year. So we see that in compared to all these years, in both the 3 months, this AOD level is less than compared to another, and it is almost nearly less than decreased by 23% than the average AOD level over another years in Guwahati area. And next we come to the next study. It is the monthly variation of PM 2.5 concentration and BC mass concentration. Blue one shows the PM mass concentration, and pink one is the black carbon mass concentration. And this red circle indicates clearly that PM mass concentration is reduces considerably during this pandemic months, because PM mass concentration is directly associated with the pandemic, so it is reduced during the pandemic year, because the vehicular activity nearly stopped during this pandemic year. So this type of concentration is very low, and it shows that a very short-term improvement of air quality over Guwahati. This shows that
Dr. Biswas, you have 1 minute. You have consumed 9 minutes, so you have 1 minute more.
Okay.
1 minute more, sorry. Okay, please conclude.
Okay, sir. Thank you.
NO2 and SO2 variation, and it's also shown that there is a low, their values is lower in the centimeter. And from the earlier value, we have seen that these values are very high in during the month of May 2021, which may be mainly due to the higher amount of fire count occurs during the March 2021, which can be clearly observed from the Moody's fire map. And these are the main highlight of my this study. This already I have discussed. And to improve the local air quality over urban location, I think electric as well as CNG-based vehicles should be used. CNG is a clean fuel and does not give smoke when burnt as compared to other petroleum containing gases such fuels such as petrol and diesel. Already one CNG fuel station has been installed in Tripura, and as far as the media, I think 3 CNG stations will be installed in Guwahati, I think. So to reduce that local air pollution over Guwahati, I think installation of this CNG station should be done as soon as possible. Thank you. Any questions?
Thank you, Dr. Vishwas. I don't have any questions in the chat box. Let me just check. Yeah, I don't have any questions. So if anyone having questions, they can send email to Dr. Vishwas. And thanks for your presentation, Dr. Vishwas. Thank you.
Thank you, sir.
Moving on to the next presentation is from Chokchom Prem Kumar Maiti from National Institute of Technology, Manipur. And title of the topic is Transport Properties of Polydisperse Hard Sphere System. Dr. Maiti, are you present? Dr. Vishwas, you can stop sharing your screen. Thank you. Dr. Maiti, are you present? If you are present and talking, please unmute your microphone. Else we will move on to the next presentation. Dr. Maiti from National Institute of Technology, Manipur. Dr. Maiti, am I audible, by the way?
Yes, sir.
Yes, yes.
Okay. So I don't think Dr. Maiti is present. So let's move on to the next presentation, which is from Nurul Alam Mazumdar. Is from National Institute of Technology, Silchar. Title of topic is Amino Functionalized Coal Fly Ash, a green and efficient heterogeneous solid-based catalyst for canonical condensation reaction. Dr. Mazumdar, are you present?
Yes, sir, I am present, sir. Am I audible, sir?
Yeah, you
Hello.
are audible. Please
Okay,
share
sir.
your screen and you start your presentation. Thank you.
Okay, sir. Okay, sir. Thank you, sir. Slide. Why it is not coming?
Share করেছো কেন share screen?
Share screen. Share screen. Start now. Wait. So my PowerPoint slide is just what is happening?
Yeah, please start. You should have prepared the presentation before
Yes,
you
sir.
come to the session.
Yes, I am prepared actually, but the slide is just little bit. It is
Yeah,
not.
quite understood. So your time has started, so you have to cover your presentation accordingly.
Yes, sir. Okay, sir. What is happening? Actually, the slide is I am trying from my mobile, sir, but the slide is not appearing right now. Sir, my slide was already given, sir. May I get the slide from your side, sir?
We have not prepared in that way actually. So I think you can
Oh,
present.
Sir, after another presentation, may I just share it? There is some problem. I
Okay,
think
let's move
technical
on to the
problems.
next presentation. And after the
Okay,
next
sir.
presentation, I will call your name again.
Yes.
Please unshare
Okay,
your
sir.
screen and then I will
Okay,
give
sir.
you another chance.
Okay, sir. Okay, sir. Thank you, sir. Unshare.
We move on to the next presentation from Dr. Navadip Singh, Oriental College, Imphal, Manipur. Are you present, Dr. Singh?
Yes.
Yeah, so your title of topic is Analysis of Thermoluminescence of Natural Salt by Simplified General One-Trap Differential Equation. Dr. Muzumdar, please mute your microphone.
Excuse me, sir.
Whom
Excuse
am I
me, sir.
talking
This is
Yeah.
Thopsom Prem Kumar. I was supposed to present before, but due to some technical issue, I was audible, but I was actually present. So can I present?
Okay, I have now invited Dr. Singh.
Okay.
So let us hear this presentation, and we will go for those presentations later. Okay, Dr. Singh, are you present from Imphal? Dr. Singh? Dr. Singh, if you are just unmute your microphone, make sure that your microphone is okay so that we can hear you. It is my request that all participants should be technically prepared before coming to the session, because there has been a lot of time, 2 years we have spent doing online programs. So if now technical things happen, then it is not expected. So I would lastly request Dr. Singh to present his paper if he is present. Else we will go to Dr. Maiti. Okay, so oral number 15IR is absent, Dr. Singh. So I would now like to invite Dr. Maiti, National Institute of Technology, Manipur, to present his topic on transport properties of polydisperse hard sphere system. Dr. Maiti.
Thank you, sir. Good afternoon, everyone. So I am Thopsom Premkumar Maite from Department of Physics, National Institute of Technology, Manipur, and present on the transport properties of polydisperse hard sphere fluids. Let me give a brief outline of
Dr. Maiti, can you hear us? Your voice is not audible. Maybe some technical problem at your end. Can you resolve that very quickly? Dr. Maiti, we can't hear you. We can see your slides moving, but there may be some problem in your audio. We can't hear you, Dr. Maiti. We still can't hear you. It is not, appears to be not a network problem. Dr. Maiti, can you hear our voice? Else we have to go to the next presentation. Okay, so we move on to the next presentation from Dr. Mozumdar, National Institute of Technology, Silchar. I believe now you are okay with the presentation. So please share your screen and present your talk. Dr. Mozumdar. Dr. Nurul Aslam Mozumdar, National Institute of Technology, Silchar. Am I audible, Dr. Mozumdar? You are there, present.
Yes, sir. Yes, yes, sir.
Yeah,
Yes, sir.
please present your
Hello.
talk, please.
Okay,
Dr.
okay, sir.
Mozumdar.
No. Sir, now is screen is shared, sir.
This is shared.
Hello.
Please, yeah, we can see that. This is
Okay.
shared. Yeah.
Okay. Okay,
Please
sir.
go
Okay,
ahead.
sir. Thank you, sir.
Thank you.
Okay, sir. My topic is amino functionalized coal fly ash, a green and efficient heterogeneous solid base catalyst for Nobel condensation reaction. So here are the contents. These are the contents. First of all,
Dr.
introduction.
Mozumdar, you please make it landscape mode.
Landscape mode.
We can't see your presentation clearly because it's very tiny. From mobile, if you know, it's very tiny. We can't see anything properly.
Okay, sir. Landscape mode.
Now, if you zoom
Sir,
in,
is it
some portions are going out actually. If you zoom in, some portions are going out. Just rotate the screen 90 degrees.
okay, sir? Now is it visible, sir?
Yeah, it is visible now. Okay, go ahead.
Okay, okay, sir. Here are the contents. So after this, this is introduction. So nowadays, heterogeneous catalysts are of very much importance due to their extraordinary advantages, such as their ability to suppress side reactions and producing better yield of the products. So noble condensation reactions are very important in looking at the point of view of the preparation of intermediates, drugs and pharmaceutical intermediates. And so here we have prepared on pharmaceutical intermediate, which is based upon the novel benzaldehyde and diethyl malonate over on solid base catalyst. So here we have prepared one solid base catalyst using fly ash, and we have prepared one solid base catalyst, and then we have utilized it in the Nobel condensation reaction to produce diethyl benzyl malonate. So in the preparation of the catalyst, we have taken 2-chloroethylamine hydrochloride and the fly ash, and the mixture was refluxed at 85 degrees centigrade for 13 hours. And after that, we have filtrated and then calcined to get the catalyst. Now, the Nobel condensation reaction is performed at between the two reactants, benzaldehyde and diethyl malonate. So after that, we have characterized the catalyst using FTIR spectroscopy, FECMEDS, and XRD. In the here FTIR spectra, we got the SIO-SI stretching at 1093 centimeter inverse in fly ash, asymmetric SIO-SI stretching, symmetric SIO-SI stretching at 781 centimeter inverse, and asymmetric SIO stretching at 565 centimeter inverse. And in the catalyst, we have got the symmetric SIO-SI at 1100 centimeter inverse, symmetric SIO-SI at 797 centimeter inverse, and the symmetric SIOL also at 554 centimeter inverse. Now in the XRD spectra, we have got the quartz, molite, and hematite as the main crystalline phases here in both the fly ash and the solid base catalyst. That is amino functionalized coal fly ash. We have performed also FSMEDS analysis. Here we have got the images. We have got in the fly ash we have seen small particles as well as very large particles ranging various diameters. And in the catalyst, we have got some typical structure where one layered type of particle is also present. And in the from the ADS spectra, where carbon, nitrogen also we have seen, from this we have also got the idea that the amino group was means the catalyst was functionalized by the amino group. And during the catalytic activity, we have seen that the optimum, that is the maximum yield of the product, was at 1:3 catalyst substrate weight ratio, and that was and the reaction, when the reaction was performed at 5.55 degrees centigrade, and the time was 5.5 hours. So after that, we have confirmed the product, which is diethyl benzyl malonate, from the 1H NMR spectra, proton NMR spectra. We have confirmed that the product is diethyl benzyl malonate. So in the mechanism, we may see that carbanion production was there due to the abstraction of proton from diethyl malonate by the amino groups of the solid base catalyst. And after that, the electron deficient carbonyl carbon was attacked by the carbanion to produce the product, diethyl benzyl malonate. So we have got one very useful heterogeneous solid base catalyst, and we have performed one noble condensation reaction, which is in a very cost effective and novel pathway. So these are the references. Thank you, sir. Hello, sir. Hello.
Yeah, thank you. Thank you. Thank you very much
Thank you,
for completing Dr. Mozumdar on time.
Thank you,
So
sir.
I don't see any questions for you. So if participants have questions, they can ask Dr. Mozumdar. You can unmute your, unshare your screen so that.
Okay, sir. And share.
Thank you.
Okay,
So,
sir. Thank you,
Dr.
sir.
Maiti, are you present now? Dr. Maiti? Dr. Maiti, you sent
Yes, sir.
one. Okay.
I'm present.
Okay, so you have solved the technical problem?
Yes, sir.
Okay, so because twice this problem has happened, I think I can give you maximum 5 minutes to just go through your presentation and highlight the main output of your work. Is that okay for you?
Okay, sir.
Okay, please go ahead. Your time starts now. Thank you.
Is my screen visible?
Yeah, absolutely
Okay.
visible. Please go ahead.
Again, sorry for the inconveniences. I will present on transport properties of polydispersed hard sphere fluid. In this particular study, I will city of a polydispersed hard sphere system having different particle size distributions. The first particle size distribution is normal distribution, and the second one is uniform distribution. So we know that polydispersity is a basic feature of soft matter system like colloids, polymers, and liquid crystals, and the study of the transport properties like viscosity and the diffusion coefficient is important from theoretical as well as application point of view. So let me jump to the analytical solution we have performed. Normally, the solution for viscosity for a polydispersed hard sphere system is done using Chapman's and Anscoke's approximation of solving the Boltzmann transport equation, which is a integral differential equation given here. So, and for a particular function f here, if we take Maxwell Boltzmann distribution for the function f, we get a simple expression for viscosity given by this equation here. So we have extended this equation to the polydispersity limit for two types of particle size distribution. The first one is the normal particles size distribution. The result is given by this equation, which is equation for the average square of the cross-section area, which is inversely proportional to the viscosity. And then this equation on the right corner here gives the viscous cross-section of the uniform particle size distribution. Both the equation recovers the monodispersity limit, which is available in the literature. And next, we perform simulation in the two types of particle size distributions using 5,000 number of particles, and these are some simulation details. Let me just jump to the results. So on the left hand side is the normal particle size distribution, and the analytical result calculated in our study with the known and scope result as well as with the simulation. So it is evident from the plot here that our analytical solution matched well with the simulation as well as with Anscoke's result for polydispersity up to 30%. We see here the viscosity first increases, attains a maxima, and then decreases as the polydispersity increases. And the similar pattern is observed for the second particle size distribution, which is uniform particle size distribution. So we, as we have already introduced in previous slides, that viscosity is inversely proportional to the square of the cross-section area. So as the polydispersity increases, we introduce particles with large diameters. So dominating effect of the large size particle is becoming more and more prominent as we increase the polydispersity. So the two competing factors, that is one from the small size particle and the one from the dominating large size particle. So as there is two competing factors, we get a maxima here, and as the effect of the large size particle dominates, the viscosity decreases as we increase the polydispersity. This we can also relate it with the momentum transfer, which is also dominant for the large size particles. So then I have compared both the distributions.
Dr. Maite, you can conclude your presentation. You may conclude your presentation.
Okay, thank you. So all the particle types, particle size distributions follow the same trend as predicted by literature. So here is also some plots for the diffusion coefficient. Thank you, everyone. I conclude my presentation here.
Yeah, thank you, Dr. Maiti. Though there was some technical difficulty, finally you were able to present your talk. Please unshare your screen.
Oh, thank you very much.
Okay. So with that, basically we had seven contributory oral presentations, out of which we have six who have presented. Unfortunately, we could not get in touch with Dr. Singh from Oriental College, Imphal, Manipur. And that's why we could not give him the opportunity to present his talk. Just before I conclude this session, I just want one comment for the participants and also for the students. You see, technical difficulties can come at any time. That is not in our hand. But I feel that some participants are not serious in practicing well before their presentation. Because in a professional body, when we go actually, we have to be professionally prepared. Okay, technical things can happen at any time. But my feelings is that if someone is having difficulty in sharing a screen, that means that the preparation is not correct or adequate. Okay, so let's learn something new so that when we go for such a program, we get maximum for the preparation. And after that, if technical things happen, that is not in our hand. Things can go weird in many ways. Okay, that is one of my suggestions to all of the participants, not only in PANE, for all. So we were supposed to stop at 3:40, now 3:52. So maybe because of discussion and other things, we had to spend some time. But it was a very fruitful session. And I thank the organizers, especially Dr. Hussain, the convener, for giving me the opportunity to chair this session. And with that, I hand over the microphone to Dr. Hussain for upcoming events he will announce. Thank you very much.
Thank you very much, Dr. Anirban, for nicely handling this session. Despite of having a little bit issues, technical issues, it was nicely conducted. So thank you very much. So dear participants, with this, we have already almost completed all the technical sessions, 9 technical sessions successfully. So now we shall move towards the valedictory session. So in between there will not be any pause because this is online. So let us continue to the valedictory sessions. And I hope Kushal, the Secretary of PANE, you are here, I guess.
Yes, I am here. Okay. Yeah.
And Professor Nimai Singh,
yeah,
President.
I don't know.
I don't know. And what about other EC members? Okay, so what I will do, let's first I discuss my plan regarding the further activities about the conference. First, I will share my plan. Then maybe as a secretary, you can discuss a little bit your experience. Then participant from different institutes, maybe one participant from one institute or state, something like that, can share views or suggestions. Then maybe our HOD chairman, a little bit suggestion or discussion. In this way, we will conclude. Is it okay, Kushal?
It's okay.
Okay. So, first of all, thank you very much to all my departmental faculty members, my colleagues, especially Debojyoti sir, chairman of the local committee, my HOD, Professor Surya Chattopadhyay, Dr. Anirban. He was always with me regarding various issues, and Dr. Roton. All of you helped me in different ways, and also thank my scholars, because you are the my main driving force. Without your support and help, it could not be possible to make it feasible, this program. So thank you very much. I also would like to thank the PANE Executive Committee, Professor Kushal, Secretary, then Professor Nimai Singh, President, and other EC members to give this responsibility to organize this program to my departments, and hopefully we have organized it in a proper way, and you will of course share your views. So thank you very much. And also I would like to thank all the participants because without your participants, any conference should not be possible, should not be successful. So it is your credit that you have participated. That's why this conference is successful and completed in a proper way. And also, I would like to thank our Honorable Vice Chancellor, Registrar also, and the University Authority for their support in various ways. So this is one issue, and we have completed almost all the invited talk, 17 except one today in the morning. There are some technical issues, and also one keynote and all the oral. Only I guess one oral was absent. Rest all presented their papers, and poster. Most of the people are present, so it was okay in this respect. Regarding certificate distribution, what we will do, we will analyze the attendance. Then we will make a list based on the eligible candidate. Then I will share the list in this group. So I request all the participants, don't leave this group till you receive the certificates. Okay. So I will share the list in the group and also website. And website will not be closed anytime, never. It will continue forever, as long as the service provider maintain it. Okay. WordPress maintain it. So it will be there. All the lecture will also be there. I will upload all the proceedings, the oral, this invited talk, keynote, everything in the website. Okay. So I will publish the list of successful in respect of certificate receiving. So if you have any doubt in this regard, you can clarify. Then I will share a Google form where you will write, you please listen, because during registration, I have seen different people written different way, name, then affiliation, then title, so many mismatch was there. So I will share a final Google form. Once the list is final to this selected pool only, you will give your information, and this information will be included in the certificate, and this will be done automatically. We will not write. So if you do it wrong, any wrong information in this form, your certificate will be wrong. So this is regarding certificate distributions. And at this moment, I am not giving any deadline, but I will try to do it as early as possible regarding the certificate, because winter vacation is also there. So, but I will do it as early as possible. I guarantee this thing. This is regarding certificate. Regarding award, there were committees, two committee, including people from IIT, different states. So they will, once they send me their evaluation report, then I will analyze it, make an average, and then I will announce. And I think it will take time, and I guess by next week we can announce the name. And this will also be announced through the group as well as website. And individually, the winner, I will contact the winner. Not everybody I cannot contact, but the group, website, and the concerned winner. And the certificate and the medal or whatever may be, the memento, whatever may be award, we will set it by post. This is regarding the award. Regarding felicitation, this time PANE and also organizing committee, we are very happy to felicitate 8 distinguished physicists of this region who has contribution in different ways to the development of physics. We are very grateful to these people. They have accepted our felicitations. So what we will do, we have read out one citation, and this is based on the information they supplied to us. We will take printout signed by the secretary of the PANE and the organizing committee, and along with the memento and other award material, again we will send it to the these 8 professors in due time. So this is regarding felicitations, and this thing will be updated in the already in the website also, and also in the abstract book I have included it. And regarding proceedings, if the people who presented your works here, if you are interested, it's not mandatory. If you are interested to publish your full paper related to the presentations, you can submit your full paper in 2 journals already listed in the website. One is Materials Today Proceedings, published by the Elsevier, and from 1st of January, actually you have to submit paper through editorial system, online system of that journal. Most of people, you know how to submit in Elsevier, and they will open it 1st January, and I will exact guideline I will give in the website and the WhatsApp group once it is open submission process. There will be a deadline also based on there will be a review also. Of course, this review may be a little bit easier compared to the normal paper. So the process again I will update in the website. So you remember the submission will start from 1st January. And now I will share maybe today night a template for preparing the paper in Materials Today Proceedings. They have already given to me in the website, so you can download. You can start on working preparation of your paper. As soon as submission process open, you start submitting. This is for Materials Today Proceeding. Another is International Journal of Engineering Research and Technology, and this is a multidisciplinary Materials Today Proceedings, mainly condensed matter kind of scope. So those who are interested for the second journal, you can submit, you can prepare according to the guideline of the journal. It is there already in our website. You prepare your paper, submit it to the conference email ID by email, and we will do some review, and if it is accepted, then it will be sent to the journal. So this is the process for these 2 journal. So I think with that, this task will complete in due time, and this is still I have to do, I guess. And now I request the secretary, Kushal, you may share your views, Professor Kushal.
Yeah, thank you very much, Professor Hussain. So this is, in fact, good experience from all of us. As being the secretary of FANE, this is my first experience to hold this type of conference in blended mode. Of course, we had many shortcomings, and what I observe is that, and in conducting online the conference, during the scheduling the routine, so we could have some demarcation, like a few minutes gap because of the technicality. So that I have observed, because it is sometimes if it is very fast, our timing, whatever schedule timing, is also very rigid. So if something happens in between, it is sometimes difficult. So for next time, so we have to plan in that way, so that if something happens also now we can say rectify that time. So maybe sometimes 15 minutes gap in between 2 program. So that I have observed. But you that in the Tripura University, all the student volunteers and teachers, they have handled quite nicely. Even in Guwahati University also, I faced a lot of problem because of the internet. So in the first day I was holding in the department, so 3 times in between the internet was cut out. But yesterday also once, but today somehow I have done from my quarter. It is also university network, but somehow here it is working fine, but it goes sometimes here and there. Yeah, but it is a nice experience. So in this sense, so I thank all the participants, because without this mass of this number of participants, so the conference could not have been possible. So I have seen the enthusiasm of the students and faculty members and participants, all from all the northeastern states, and we look forward, because they are the main motive, or they are the driving force for all northeastern states. Of course, some of the participants may not be as of now the life member, of Physics Academy of North-East. So I'll upload in the website if they want, no, they can be live members of Physics Academy of North-East. So that is my one proposition, like one request to them. So they can, because today we are in the office bearers of Physics Academy of North-East. So in another day, so those students or those faculty members could be a member or office bearer of PANE, and they should run this PANE, because that is the only way it can flourish. That's why. So there should be a part and parcel of this society, and at the same time it will be beneficial to them. And because many times the students do not get how to get good informations regarding research and regarding the collaborative work, means in Northeast India or maybe in national institutes or abroad. So we can give them instructions at any time. And very soon we'll also launch one PANE website that will be private. So I can give assurance to them. And I congratulate all the participants. So mainly who will be getting awards in oral as well as in posters. And I should also congratulate all of them, but who are also not getting, will be not getting awards, but they are also trying for their level best. So with these few words, and again that I for the shortcoming which we could not give them best say facility, but till we somehow we did this 3 days conference in Tripura University, which is the one of the best university in the Northeast India. So I congratulate all of them, and with these few words, I wish all of you great success in future endeavor. Thank you very much.
Thank you, Professor Kushal Kulita, for your nice words, and to the participants also. Yes, you rightly mentioned we face some issues, and you know this is a learning process for us also.
Yeah.
Because it was hybrid mode. But one important issue, all participants and every one of us should remember that this is a reversible process, two-way process. In one part, we are the host. In another part, you are the participants.
Yeah, sure. Yeah. Yeah, that is the way. Yeah. Go hand in hand. Yeah. Yeah. It is not clear. I think this is network issue.
If you have to go to your friend's house or other. You see, I have seen some people presenting from mobile also. This is not expected. And you people and the people who is presenting from mobile, they have already completed PhD. Some college professor. Nowadays, everybody is having laptop. So you have to be serious. This is my suggestion, not criticism, no nothing. My suggestions, because program will be successful if we all, because we all are a team. We have to work as a team. So everybody of us should take the responsibility to make the program success. This is from my part. And of course, I beg, apology for the shortcoming. And in near future, we will try to make it in a better way. So now I, from different institutes, if you want to share your views or experience or suggestions, one by one, you can share, I think. You can unmute your mic and then
Good afternoon, sir. Myself is Josna Soikia from Department of Physics NERIST. First of all, I want to thank to the organizer for giving us an opportunity for presenting our work on PANE 2021. And I'm also thankful to the organizer for organizing such an informative sessions. We gathered a lot of knowledge on different fields of physics, and it will surely help us in our further research work. And thank you so much, sir. Thank you.
Good evening, sir. I am Angeline Sharmila from Queen Mary's College, Chennai. I am from South India. I would like to thank the organizer, convener, who made this conference open to South Indian students also. I contacted Hussein sir. He was very much available to me. Whenever I had a query, I was able to contact him and he cleared my doubts. And the sessions were very good. It was meticulously planned and well executed. And thank you so much for allowing me to present my work in this wonderful PANE 2021 conference. Thank you so much, sir.
Thank you, Madam Sharmila. Thank you for your nice words and experience. So I see one query from Rizwana Haq. She wants to know whether single paper can be submitted for both the journal. No. You cannot submit single paper in both the journal. You select a journal based on the scope of your work or whatever you think best for you. Okay, best. Then you submit. This is, I think, better. You cannot submit same work into journal. It's not possible. So maybe next one, if someone of you can share.
Good evening to all the members. I am Shomik Mitra from IIT Guwahati. Am I audible?
Yes.
So first of all, I'd like to thank all the committee members of PANE 2021. And it's a very great experience for us to participate in this. And thank you for selecting my work for the oral presentation. And it was a very nice and interactive session. I enjoyed and I got lots of information. So thank you. And hopefully we will see in near future a physical conference or workshop like this, because this was online, so we couldn't meet everyone. So that would be a great thing. Thank you.
Yeah, sure. In near future, maybe we will overcome these situations. We are optimistic soon. Our health sector is also, progressing, and they are working very hard to develop the solution, and it will be resolved soon. I am sure about it. Regarding this oral and poster, as far as my understanding, I think poster is more better for interactions, even physical mode also. Because if somebody is speaking oral, maybe 5 minutes, 4 minutes, it's hardly difficult to catch the matter. And interaction also very less. But for poster, somebody will go, read, and even if don't know, then he will ask what you have done. In this way, interaction started. My friends in different parts of the globe also, I see they are interested in posters. Big professors, they are giving posters. Here also, you see, your poster, your presentation is uploaded in the website. It will be there for long time. So even in off time also, people can see it. If they are interested, they can mail you also.
Yeah, the time for oral presentation is also probably so little less. So it could be 12 minutes or something like that. It was in a hurry, in fact. Yeah. Next time we can extend it little, say 2 minutes more or so. Yeah.
What happened?
Voice is getting cut.
Yeah. Otherwise, for physical, normally PANE, always there is parallel session based on the topics and
Yes.
larger number of oral also. So we will take care of these things in near future. So maybe participants from other places. Okay, so now I know that there are some offline participants also in my place, almost more than 70. So some of them will also share their experience.
Yeah, it's
so let
better.
us, let us allow them to share. Then again we will interact with online people. We have another 20 minutes, so maybe.
Good evening, everyone. Myself, Devaditto, 7th semester student, BSc B.Ed, Tripura University. It was a great experience for me being in a physical, in a hybrid, actually, hybrid mode national conference. Thanks to the PANE and also Department of Physics, Tripura University for organizing this event after pandemic. The last conference I have attended was in 2019 offline. It was an international conference. After this COVID, this is my first hybrid session. So I was very excited for that, and they meet my all expectations. And yeah, I can say this is a great success, and that's all from my side. Thank you.
Anyone else? Anyone else from Tripura?
So it was a nice experience to be in this hybrid mode program. At the same time, from the organizing point of view, it was also challenging. At the same time, it was adventurous. It was highly cooperative in the nature. We worked hard very with all the students, all the scholars, all the teachers. They have guidance us. So it was a nice experience all in all. And thank you, Pane, for giving us this opportunity to be here and present ourselves in this way. Thank you.
Thank you, Ritanova, for your suggestion, words, feelings, sharing your feelings. So I remember Professor Onulu was with us for all the oral session. So may I know if Professor Barua is here with us?
I don't know.
Professor
Yeah, he's here.
Onurup Gohen Barua.
I don't know whether he's here.
He was very active. You know, he already mailed me his evaluation. He has attended all the oral sessions, and he now messaged me that he has sent his evaluations. So I would be very happy if he can share. But if his absence still is okay, you convey my thanks and
sure.
also
He's
I
not
acknowledge
here.
him.
Yeah.
So from my departments also. So I see Professor Nimai Singh has joined. Sir?
Okay. Is it?
Nimai Singh? If you want to say something, I see a lot of videos, faces.
Yeah, all girls now sitting at home, probably our department. They want to
So
say
if you-
something. What is happening? They are now relaxed. They are taking relaxation. You just see the faces. Now they are laughing, smiling. Now, so they are now relaxed. At least their
Okay,
presentation is over.
so let us move further.
Yeah.
Debojyoti sir, you are here? Debojyoti sir?
Yes, I'm here.
Okay, so now I request the chairman of the local organizing committee. He guided us. He suggested us in help us various way. He was active throughout the program. He listened all the sessions. So I request sir to say something in this valedictory action. Sir, please.
Okay, and first of all, I thank the organizers, especially Professor Arshad Hussain and Dr. Anibar Guhu, to organize, and all the scholars of the departments to organize this hybrid mode of conference very nicely. And I think that and also I thank my sincere thanks to all the participants and the secretary and president of Penny for their active participation and active encouraging the situation. And I think that this hybrid mode of seminars and presentation and seminars and conferences, these are the next generation, our future alternative. And you see that our department organized a large number of international and national level conferences in offline mode and also in webinar mode. But this is the first time that we organize this hybrid mode of this presentation. And in this hybrid mode, the participants from Tripura, they can present in offline mode, and all the other participants from other states. And even you see the distant parts from Tamil Nadu, Kerala, they can also participate in this by online mode. And not only that, but you see that in this hybrid mode of presentation, and even the invited lecturers from Israel and Germany, they can also deliver their valuable lectures. And in these types of hybrid mode, if we can just again organize these types of hybrid mode of presentation, then also we can invite some other distinguished lecturers from Japan, USA, and others, and we can easily access them, and we can also learn their valuable lectures. And if necessary, we can communicate them with by email and or in other modes. It's no problem. And I think that also it's no doubt that to some extent this offline mode of presentation is okay, but this hybrid mode, it just opens us this opportunity. And actually this COVID-19, it opens us this opportunity for this webinar and hybrid mode of presentation. And actually you see that just before 2 years ago, we were not aware about this webinar type of presentation or this hybrid mode of presentation, but now all of us are expert. And also you see that just today and yesterday, I also checked all this poster presentation, and most of the presenters, they nicely present, they nicely recorded their lecture. And actually in this ICT mode of lecture or classroom teaching, it was always instructed to present, to digitize your note and also prepare your video lecture. And I think that our next generation, they are now already prepared to how to prepare the video class lectures and others. I think that our students will be highly benefited. And not only that, if you can just share your video lectures, class lectures, then a large number of students, we can accommodate a large number of students, and they can be promoted in their higher education in physics, chemistry, and also in any other technical branches. And I think that Penny, this conference, that we learned a lot from these Penny conferences, and our younger generation also learned that how we can run these types of ICT mode of education, and also can run this hybrid mode of conferences. And also maybe that in near future, this time is coming that we can also start taking classes in these types of hybrid mode. And also you see that during this pandemic situation, when students were not allowed to come to the classes, then these types of virtual lab, already some IIT Mumbai and other institutes, they already started the virtual lab. We also took the help of this virtual lab, and our students are highly benefited. They were highly benefited to use these virtual labs. And maybe that this is the next generation mode of teaching. And quite slowly, we have to transfer this type of mode of teaching from this present classroom mode of teaching. Okay, and thank you all, and best wishes to everybody, all the participants and organizers. I am now stop my lecture. Okay, thank you.
Thank you very much, sir, for your views as well as suggestions. Yeah, I also do agree with you. Maybe our future it depends mainly on the ICT mode, and it should be obviously hybrid mode, because there should be a component of physical interactions and of course online or with the help of ICT. So we will make the teaching system, learning system in a more effective manner. We will do it definitely. Now, Professor Surjo sir, you are here. Surjo Chattopadhyay. Surjo sir, our HOD. So maybe he is not
Professor
here.
Nimai Singh has come.
Okay.
Nimai
So
Singh sir has joined.
Professor Nimai
Hello.
Singh.
Hello.
Surjo
Hello,
sir, you
Arshad.
are here.
Yes,
Okay.
hello. Yes. I am Nimai Singh. I am also with you now.
Yeah,
Okay. So let us first say the few words by our HOD, then Nimai Singh sir. So Surjo sir, please share your
Hello.
views. Yeah, we are
Hello.
hearing you. We are hearing you, sir.
Okay. Actually, we are very happy. I am on behalf of physics. I am telling you that we are very much happy. Yeah, because we have organized this program, PANE 2021. I think all the participants are benefited from interactions with different resource persons, and it will be helpful for their future research career also. Okay, so I have nothing to say more. So I am congratulating Dr. Professor Arshad Hussain, Professor Debojyoti Bhattacharya, all my departmental colleagues, Dr. Ratan Das, Dr. Anirban Guha, all the research scholars and our students, and Professor Nimai Singh and Professor Kushal Kolita, the PANE PANE president and secretary respectively. So we hope that in the next conference will be a more organized in a more sophisticated manner, and I think it should be in offline mood. We expect. Okay, so I am concluding my
Thank you.
talk.
Thank you, sir, for your appreciation. It was nice. So, Professor Nimai Singh, can you share your
I have nothing to say more, but since you have asked, so first of all, I will thank Professor Hussain and his team for organizing this wonderful 12th Biennial National Conference of PANE. It is indeed great in the sense that you have combined in a blended mode, online, offline together. And in fact, this kind of conference was already there before COVID pandemic, long time back. Many international conference, in many international conference, those participants who could not attend physically, they are given this chance. That I heard long time back before this pandemic. Now it has become a reality here also. And a second point, in many universities abroad, PhD thesis examination, online mode, viva. This thing, it was a miracle for us now during the pandemic. It has become a reality. I hope that the experience gathered by Professor Hussain and his team will be transferred to other university when they organize the next PANE conference, the hybrid mode. But if it is a normal time, we should still keep some option for online this, because those participants who cannot participate physically should be given the chance, even the speaker as well as the participant. That is a must, a lesson we learn from this very conference. That's all. And I again thank our Kushal Kolita, Dynamic General Secretary, for bridging the gap between PANE headquarters as well as the university where this big conference is organized. With these few words, I thanks once again all the participants as well as the organizing team of this wonderful conference. Thank you.
Thank you, sir, for your nice, inspiring words. Yes, I do also agree. In future also, next conferences, there should be a component of online part. Those who will not be able to join physically, they should be allowed to take part through online. So I see Professor Dilip Chaudhary. DK Chaudhary is with us. So may I request, sir, you to say a few words?
Yeah, I'm really very happy to be here. In fact, I attended the first day meeting, and I really thank you, the convener, the president, and all the members of PANE that this conference is very success. And just as our friend Nimai told me, I think even in future we should have this also. I mean what is the hybrid mode, both online and offline. Okay, and that has really made say a person like me. I'm not gone department for several days, but now I'm today at home. I'm listening to all the talk, most of the talk. So I think that's a new thing for me, and I think as the every future almost think of having some kind of, I mean, hybrid mode. And in fact, last 2 years people are talking about it. I mean, there are many articles also, even media journal. I mean, that for senior people like us, I mean, that has really become boon. Like, okay, we're sitting at home, I can hear all the talk. So that's an experience for me. I think that PANE will survive. Coming 500 years, I hope to cross the present age of INSA as well as the Royal Society of London, as well as French Academy of Science. So I would say at least it will last for coming 500 years. I hope so. Okay, thank you.
Thank you very much, sir, for your words. Because personally, for me, I learned about PANE from you, and that time
yes, you are my student, right?
You are always with PANE, and in future also, we think you will be always with us. So thank you very much, sir, for your nice words.
Okay.
So now I see Professor Borua, Anurup Gohen Borua has joined. So if Professor Borua, you can share your views regarding the program, say, because we have to go for this PANE meeting also. So
Professor Barua is our very dynamic executive president of PANE present. Okay, you emphasize.
Hello, good afternoon to you all. So I listened to all the oral presentations, but not all the invited talks. And yes, talks were good, and especially the organizers did a very good work. I mean, it's not so easy to organize a conference like this in the pandemic time. So they have done very good work, and from whatever I can see, that it's a success. In fact, a grand success. But well, once because it was a competition type of thing, no? This oral presentations. So the network problem on occasions, it was a hindrance. Plus, in one session, suddenly the participants were asked to curtail their talk up to 6 minutes. So that way they definitely faced some problem, because some of them were very young. These things occasionally happen. But apart from this, I think it is fine, very good. And I also enjoyed this. Special thanks to Professor Orsat Hussain. So thank you.
Thank you, sir. I also do agree with you regarding this time, shrinking. Actually, in physical mode, we could have, request the chairman, but now it's remotely, being controlled. So there is gap. So we even if we try to call by phone, then again maybe problem. So we didn't do anything, but I completely agree with you that at least young people, they should be encouraged, they should be given the time, even more than us also, what I feel, because they are our future generations. So Dr. Oniban, he is my colleague, and he was the main instrumental person regarding the technical part. So Dr. Oniban, if you want to say something, please.
Yeah, okay, thank you. First of all, we would like to thank the PANE general body to provide us the opportunity to conduct this conference. It was a challenging task for us, but what I learned from it here, I would like to pass this message on to the students and research scholars, because when we are getting older and elder and more experienced, we will be dependent on them in the future. So the thing is that whatever technology is here, we have got lots of appreciation, and thanks for these appreciations and inspirations that will give us more impetus for doing better work. The thing is that the most challenging thing that I feel, that is the manpower management. Whatever be the technology available, maybe in the past the things were different. In the future, more technologies will come that we even don't know, even within 10 years, what is going to come. Okay. Some technologies are in defense, then they go to civil. Okay. So, but we have to be dynamic in such a way that manpower management becomes a very important component for anything to get success. So we have learned a lot personally. I was planning in my diary. I carry a diary actually always. Even if I say to my students that whatever technology, IT, ICT you have, you cannot leave a hard copy of diary. And I noted down everything in a planned manner, but things did not happen as planned. So that's why we learned that we have to manage manpower very well. Apart from that, all the senior professors, all the research scholars, even the students, when there was time for lunch, when there was snacks distribution, because it was a hybrid mode, every one of them was so encouraging and so helpful that without their active support, it was not possible. When I asked for manpower support, I got it like in a flash. I sent a WhatsApp message, the things are executed within a flash. So this can only happen if we have a professional manpower going on, and I would like to wish all the best for the future generation so that they can take proper message from this conference and how it is done, so that they can apply it in future for such organization, not only conference organization, but in their life, so that things getting much better. I thank all the professors, especially Surjo sir, Deboti sir, Arshad sir, Ratan sir, all the staffs, students, and untiring effort of all the research scholars, especially for making this conference a great success. Thank you very much. Thanks.
Yeah, thank you, Dr. Ratan. So maybe we can have a last comment from one of our invited speaker. I can see him, Dr. Faizuddin. So if you want to share your views, you can share. Then we go for a conclusion of this session. Please. Faizuddin, can you hear us?
Probably he's in a bus.
He off the mode. He didn't put he off the microphone. This is
yeah.
Okay, no problem. Okay, so let us conclude this session. And regarding this conference, the group will be, WhatsApp group will be there as long as the future activities of this program is not finished. I will not close it. Okay, I request the participant also you be here, and you can email me also. I am available till the publication of the paper. Okay, I am available. Later part also available, but regarding this program, I assure you I am with you all. Okay, so I again thank you very much, all the participants and all my colleagues, all PANE, everyone, all the physicists who have contribution in various ways. Thank you very much. So let us conclude. Devuji sir.
Okay.
So as a chairman, you can conclude this program. Then we will move to the meeting.
Yes, now it is better. Now I am declaring this session. This conference ends here. And now you may go for this PANI GB meeting. Okay.
Thank you very much. Thank you very much, sir. So Professor Kushal, as a secretary, now you can take over the charge of the meeting.
Okay. Now
Yes.
I am leaving.
Yes, yeah.
No, sir,
So
you can
that-
be there. There was, sir. You are also a PANE member, so you can be there.
Yeah, this is PANE general body meeting. So all PANE members can be here. Yeah. So Professor Dimai, are
Yes,
you
yes.
available? Yeah.
Yes, I'm available. I don't know,
Yeah. So,
my camera is not working, but
working?
anyway,
Okay, no problem,
I'm
no
here,
problem.
no problem.
So that everything goes fine. So now that the general body, I think that all live members will come, or it is coming. I don't know how many numbers has come, but for next place of conference, so one request has come from Manipur University, Department of Physics, Manipur University. This is from Dr. Gumti, and that it is that departmental approval has given. So for that 2023 conference could be in Manipur University.
Professor Kushal,
Yeah.
hello.
Yeah.
Even though I am also from Manipur University,
Yeah.
I should not give much remark, but as a president, I should not give much remark. But as I know about Manipur University, hello.
Yeah.
Recently, we have added 5 fantastic faculty members.
Yeah.
In addition, and another few more online. So will be coming very soon.
Okay.
So in that way, our faculty member in physics department will be increased up to near about 15 or so. So
it's
in
good.
that way, the claim made by Manipur University Physics Department is worthwhile. Okay, that must.
Yeah.
That must.
We because it is response to my that email sent to all life members. I requested there. So if someone is having the letter of intent, or say they want to conduct this biennial conference in 2023. So that only one request I have got so far. So that is my concern. Yeah.
So Professor Kushal.
Yes.
If we have received only one, then we should go for that. Because if there is more than one, then we can compare the facility or whatever may be. This is my one point. Another point, this 12th conference was supposed to be organized during 2020.
Yes.
So 13th should be on 22, not 23.
Okay.
If we maintain, and it is possible also, and it's good for scholar also.
Okay.
So,
yes.
So if you all think, then you can think in this issue.
Yeah. If all bodies agrees, now we can put this to organize in 2022.
Yes. 22. Right. So yes, in between this October and December. In between October, November, December, like this. Okay. In between.
During that period. Yeah.
They may decide the best time.
That working days. Or...
I think let us take this decision. Okay. We support Sarhusen, Professor Sarhusen. Okay.
Thank you, sir.
I fully support this idea to organize in 2022 at Manipur University.
Okay. Manipur. Yeah. So that year should be like earlier it was mentioned 2023. So now it has to come to 2022. So what about department Manipur University? I don't know whether Gumti Devi is around. Dr. Gumti Devi or Professor Nimai Singh can tell something.
Yes, I advise Gomti Devi to take care of and to consult head of department and the DSC meeting to get a letter. So I will convey to her, and I saw many students from Manipur University.
This year, yes.
Yes.
Yeah.
So they are free to choose the dates or months, maybe last part of the year.
Later part of the
year. As per their convenient.
Yeah, this is the tradition. Yeah, yeah, the Professor Bidildam Zero ma'am is present. Yeah, she can also tell something.
May I suggest something if it is
Yes, yes,
feasible?
ma'am. Yeah.
You know, what I find from teaching at the postgraduate, can we think of expanding or including the class, at least class 12 level? Or we are concentrating only at the university level? Because
Yeah.
grassroots foundation is very important. And
Yeah,
I find that people coming, I mean, with weak grassroots, their
Yeah.
knowledge is they cannot apply. They can rattle off Newton's laws, but they cannot apply in many cases.
Yes. I mean, Madam is saying students from 12th class onwards, they can be a member of PANE.
Yes.
Yeah.
And
so-
let us have a sub forum for them.
Yeah, some
Can
forum,
present
yeah, yeah.
something.
Yeah, Professor Kushal, I have
Yes,
one
yes.
suggestion in this regard. I
Yeah.
completely agree with Madam because this will serve the input to the physics community in
Yeah,
graduate
yeah,
as well as postgraduate degrees. This is very
Okay.
important. So PANE
Okay.
should have some kind of outreach activities because even if they participate in this kind of programs, it will not be useful for them, for school students. So we can make a separate chapter or section for them, and
Okay.
PANE
Yes.
will do some activities. Earlier it was there by the DST Inspire. We used to
Yeah.
invite school students and then inspire them towards basic science, towards higher educations. So PANE can arrange this kind of activity maybe once or twice in a year, or
Okay. That
invite
is noted. Yeah, it
students.
is good point.
Nowadays online also possible, so it's very doable.
Professor Kushal,
Yes. Yeah.
there was some similar suggestion for undergraduate also.
Yeah, from Bikesh Sharma.
Undergraduate also, let us have some dedicated program for undergraduate also, maybe
Yeah.
about 2 weeks intensive Inspire program also for undergraduate, or at the same time, now Professor Joya also suggested for
Yeah.
12 class also fine. And we have for mathematics, they have mathematics Olympiad conducting very well in Assam and Shillong, but for physics, nobody volunteer in Northeastern also.
In fact, for Assam Physical Society, so last 4 years we have conducted Physics Olympiad.
Oh, very good, very good.
This year, last 2 years we could not hold it because of the
Very
pandemic.
good. So,
But it is in process. Yeah.
Yes, please. By the way, so to start with, I don't find any merit for them to be the member because we have certain our constitution who will be the member, huh? At least MSc Physics, huh? That is our minimum qualification to be member. So may not be may not be member, but whenever we have a program, they may be requested to register. Okay.
Yes.
They may be called to register or to enter their registration. Okay. So so there may be some techniques for that matter.
Yeah, I don't think of. Yes. Yes. Any other suggestion?
One more suggestion, if it is possible, can we have some sort of talks, let us say, on Nobel Prize winners, supposing this year, who got the Nobel Prize and for what? So if we can have a talk once a while like that.
Yes,
ma'am,
yes.
Just among the PANE community.
Yes. We have to search the resource person. Once it is fixed, then we'll be in communication. Yes, ma'am. Yes.
In this regard, Professor Kushal,
yes,
I remember in one of last EC we decided there will be a talk for each month.
Yeah, each month. Yeah.
Highlighting the activity of different group or different advancement of physics, something like that.
Yeah.
So is it operative or yet to start?
Yeah, because of the some of the problem, no, but it is in process. So, for example, so
what I
we will be-
suggest,
yeah.
So you see, for one person arranging in every month, for example, for you it's difficult. So
Yeah.
what you do, you can give assigned responsibility. For example, you can tell me, Arshad,
Yeah.
you arrange in next July.
Yeah, I have to in that way. Yeah.
Yeah, I will arrange in July. For
That's
example,
right.
madam, you arrange from your place, and Pane will give the support,
Yeah.
manpower, whatever may be communications in next December. In this way, you can make a calendar. So we all know that there will be some program month-wise. So you can do this kind. Otherwise, it will be a pressure for you. So this
Yes.
is my suggestions.
Yeah, it should be decentralized. Yeah.
Kushal, sir, can I suggest one thing?
So
Yes,
in
yes.
that way, 16 December,